A very good morning to everybody, and once again we would like to welcome everyone to IPWE 2023, the second day in Pune. The property where you are is a blend of Pune and Egypt together. How many of you visited Pune before? All right. Ladies and gentlemen, put your hands together as our chief guest for day 2, additional member Civil Engineering Railway BD, Shri B.K. Gupta sir is here, and let's give him a huge round of applause. And we need to see your claps up and high. Thank you. So sir, with your blessings, Shri B.K. Gupta sir, do we have your blessings? So sir, if we do something different this time, may I request you to please join here with your phone on the stage. Start कर देना है, शुरू कर देते हैं, चलो. So now, my name is Nitish Kamdar and I welcome you to the Technical Session 3. We are running a little ahead, but it's completely fine. I request all the authors who are going to be presenting their papers to kindly stick to the time. And also, let's cut down on all the time of acknowledging everybody's presence and wishing them good morning and good afternoon. Thank you so much. So let's keep it very precise. Let's keep it very substantial. So with this, it's time for us to put our hands together and invite the chairman and the co-chairman. So can we have Shri D.K. Chandrakar, CETP Central Railway, kindly escort our chairman, Shri A.K. Mittal, former member Engineering Railway Board, to the dais, please. And we also request Mr. Rajiv Mishra, CEG, to kindly escort our co-chairman, Shri Ashok Kansal, former General Manager, Western Railway. There are going to be a total of 5 papers. So with us we have the chairman, Shri A.K. Mittal, former member Engineering Railway Board, and co-chairman Shri Alok Kansal, former General Manager Western Railway. Now, without any further ado, gentlemen, kindly let us know, what are you looking forward to in this technical session? It's on, sir. Check. Hello. Hey.
What is the time frame you are giving to the...
So we are giving 10 minutes to everybody. Of course, this will go on till 11 a.m. 11 a.m. is the hard stop. And right now the time is 9:32. So we have 1.5 hours and 5 papers.
Good morning to all of you. There are 5 papers in this. 5 papers in this session. 4 are regarding the bridges and structures, and 1 is about the laying of track through yards in the form of continuous welded rail. Very good papers. So I now request the first author.
May I invite?
Shri Parmeshwar Funkwal and Harsh Kumar and Chirag Mittal and Mr. Ghaffari. Thank you.
So the first title of the paper is the continuation of CWR through station yards, experience of Western Railway in laying and maintaining Indian Railways' longest CWR. And presenting is Parmeshwar Funkwal. All right. So let's start on a positive note. Let's give all of them a huge round of applause. A very good morning, everyone. Over to you, sir.
Thank you, and very good morning to Chairman sir, Co-Chairman sir, Chief Guest Sri AMC sir, and my senior colleagues and colleague officers. It's a proud privilege to be presenting the first paper today morning in front of many seniors actually who have contributed to our knowledge base, our understanding of the subjects, and guiding us in the administrative capacities. So I would begin my presentation. Basically, this is a very small beginning as far as Indian Railways is concerned, but having huge consequences. If we take it through, it is going to have huge consequences for Indian Railways. Basically, what is CWR? CWR is nothing but LWR taken through points and crossings. And these are the three main components, which special components I would say. Other components are available already with the PWE engineers. So weldable CMS, thick web switches, and anti-creep device. These are the three things we need before we start converting any LWR into CWR. And see, the enabling provisions for Indian Railways are very recent in origin. And it started with RDSO report CT48, which was published in August 2019. And then thereafter, Railway Board issued a letter in that year itself to zonal railways for continuing say LWR through points and crossings in one of the yards in every division. And later on, this provision of IRPWM came in when IRPWM 2020 was published. What it means besides the better riding? Actually, when we eliminate joint, better riding is just a byproduct. But what else it gives us? See, in terms of huge savings in terms of manpower, inspection and maintenance manpower. We see the SEJ inspections, every 60 days it is inspected by supervisor and above. And SEJs are potential source of, fractures. So we have almost 140 either IMR, rail brakes or cracks in the SEJs in 1 year. This is the trend over other years, previous years also. So besides that, attention to SEJ, that is also every now and then we require attention in order to maintain a satisfactory riding quality. It eliminates 80 welds, we all know. I won't elaborate on that. Bolt hole, again a potential source. Once we have gone into LWR, then bolt holes are the constant irritants to our safety. Fish plated joints, of course. So all these benefits, they accrue when we take LWR through points and crossings. Very limited experience, as I mentioned, early experiment in 2003 in Rani Kamlamati, but then it was not capitalized on. Something sincere started, in fact, with NCR providing one of its first CWR through Chamrola yard. And in that case, the far end SEJs of the yard, they were retained. Then a huge stepping up came in with the adoption of CWR in the Western DFC and Eastern DFC in 2019 onwards. I won't go much into this. These are all parts of CT48 report, but only thing I want to emphasize here is that there should not be any unserviceable sleepers, ineffective fittings. These are the things which we need to take care of if we want our CWR to become successful. So our journey with CWR, in fact, we selected 160 kmph route as mandated in Railway Board's letter. We started with a milder temperature zone so that we can gather some experience and build on it. We ensured compliance of CT48, what is the level of compliance at a particular yard before choosing, and also the ease of close monitoring, because in initial period we wanted it to monitor very closely. So we selected Vadodara, Godhra, Rajdhani route, where the GMTs are shown on the slide. Speed current is 130 kmph. So Chayapuri yard was initially taken up, and then later on we extended our CWR on downline through Pilol yard also, that is adjoining. So making that CWR length as of now is 19.68 kilometers. And on upline it is 6.86 kilometers. So this is again the compliance levels and the time when we converted this LWRs into CWRs. These are the previous and the current layouts prior to and after conversion. So as you can see, we have eliminated, in case of Chayapuri, we have eliminated 8 SEJs, and in Pilol, we have eliminated 6 SEJs on one line. Now, this is a very important slide, because here lies the crux of how do we successfully lay and maintain CWR. So sequence of welding in the point crossing zone is very important, and this is a gap. Presently this is a gap. We have not specified anywhere as to how we do the welding in the point crossing zone when we are converting it into CWR. Of course, in our case what we did was we eliminated the inner SEJs first, and then behavior was kept under observation for some time. And then when we gained confidence, we continued through the yard and taken to the complete next block section. The diagram below, we can see that these are the numbers here indicate the sequence as to how we should go about welding. This is a very important component, that is anti-creep device, and this is nothing but a communicator. We should not take it for that whether it is going to stop our creep. Basically, this is nothing but a communicator. It tells us that whether our CWR is behaving properly and whether any intervention is required. So it is a telltale device. It is centralized fixation of this is very, very important. RDSO drawing exists. We have prepared a very small video. I will not show it here. Link is available. All people who are interested can go through that video. It's a very good video which indicates all the necessary things which are required to be done for installation of anti-creep device. This is a picture of actual site where we have fixed the anti-creep device, maintaining the centralized position. Now, once we do that, the entire concept of converting CWR is that in a length of around 110 meters, the entire resistance to the LWR forces that develops. So we must see that our fastenings are effective, and therefore we must keep on observing if there is any creep in the. So these are the locations where we must monitor creep and see if they are within limits. These are again here I would lay emphasis on the tow load, because the calculations say that we need to have an adequate tow load not below 1000 kg in order to maintain the proper gaps at SED and to have a successful CWR. So story so far is this: we are having satisfactory performance. There are some red flags. You can see the yellow highlighted portion where we have reached up to 1 mm gap. So we are closely monitoring. One of the CWR is now, it will become 1 year in January 23. We will keep a close watch and see what is the behavior. But so far it is satisfactory. These are the plots. I will not go through in detail. This again I will skip because riding improvement is again a byproduct. Some areas which need attention is our WCMS quality and the technique, because we have observed horizontal cracks in the web portion where trimetallic junction exists. We have got some surface issues with the CMS crossing and the lip formation at the trimetallic junction. So these are the issues we need to address, because replacing this WCMS would not be a very good idea once we convert it into CWR. Further areas which needs attention is that our current length of WCMS, there are constraints in welding and grinding. The length needs to, I will take just 1 minute more, sir. So we need to increase the length. We need to have a credible method of stress-free temperature measurement, because we cannot intervene every now and then. We must know when to intervene and when it is absolutely essential. So stress-free temperature measurement is very, very important. We need to have various protocols in place as to how to deal when an unusual occurrence takes place. And another one, this thing is that now with the elimination of all the joints in point crossing zone, the only irritant which is bothering us is the glute joint. So we must do something to, at least on 160 kmph or 130 kmph and higher routes, we must specify that the glute joint should be eliminated from the yard. And continuous welded rails, continuous improvement, Kaizen, that is what we want to achieve. Thank you very much.
Thank you, authors. Co-chairman, would you like to say something? So we have questions for them. So just once again wanted to reiterate that if you have questions, our volunteers are present right there and you can mention your questions and they will pass it on to the authors and the speakers. Just raise your hand and our volunteers will come and see you. Over there, sir. In the meantime, we would like to invite the next paper.
So,
the title, yes,
okay,
please.
please.
The title is Challenges in Continuation of LWR on Long Bridges and Their Possible Solutions. And the authors are Shri Satya Prakash, ADG, IRISEN, Pune, and Shri S.K. Agarwal, Professor Bridge, IRISEN, Pune.
Okay, so can I take the question?
Yes, sir.
Okay, so this question is from R. Nand Gopal, Deputy CECN, Madurai. The question is how thermal stress built up due to temperature variation is eased out. Any theoretical calculation study regarding this available? Yes, of course it is available. CT48 has a theoretical calculation. It shows how the, how much force is developing, how many numbers of sleepers are required to, counteract that kind of force. And as I mentioned, that this particular portion, that is points and crossing, part of that behind crossing and the plane track. So 50 sleepers, 60 sleepers in points crossing zone and 50 sleepers on plane track. They actually take part in building the resistance to LWR forces when we take the LWR through points and crossing. Part 2 of the question, restraining movement or allowing stress built up will not lead to buckling. Okay, so buckling is a very serious issue, and when we convert it, there are precautions. One precaution is that point crossing is a rigidity is having a higher rigidity as compared to your plane track, and therefore any built up of stress at this location can create problem. Now the anti-creep device is the one which is going to tell you that whether the forces are becoming way beyond. In fact, the moment your ACD gaps start telling you that, okay, it is closing, that means it's a red flag. You have to intervene there, you have to find out that what is the reason. In fact, for this reason, Western Railway has specified that the tow load measurement in the CWR must be done every 3 months to ensure that there is no loss of tow load below 1000 kg, because 1000 kg is the limit which is theoretical calculation in zone 4. It suggests that if it falls below 1000 kg, then your ACD gaps are likely to be abnormal. Hope I have answered your question.
Thank you. So we'll be taking rest of the questions towards the end.
Right.
All right. Sorry, if I may. So we really appreciate there are many questions which are coming our way, and that is really great, and it feels that now there is a lot of engagement happening between the authors, between the chairman, co-chairman and every delegate which is present out here. So it's just a sincere request, kindly mention all the questions which you have, whom are you addressing it to, your name, and accordingly kindly share it with us, because we'll be taking all the questions towards the end and we'll be inviting all the authors together. So let's do that. And now over to you, sir.
Respected chairman and co-chairman, sir. Respected seniors and friends, the elimination of joints has been our endeavor since we started our career, and as we know that we have laid lot of LWR from station to station. Our friend have started the LWR through turnouts, I am working on eliminating the joints from bridges for last many years, and I also did the work on LWR through sharp curves and steep gradients in way back, and now the trials have been completed and its report, RDSO submitted report to Railway Board for issue of necessary orders. So last year we did a presentation on LWR, continuation of LWR open deck bridges. That report also we have submitted to RDSO and Railway Board. We have also submitted a proposal to set up laboratory in East for lateral and longitudinal resistance of H-beam sleepers with full toll rope fastenings. That also we will be doing. Today we are taking up a special case of WCR where LWR, actually the continuation of LWR RSA analysis was done, but they referred to us for confirmation. We checked it, then we found that it is not okay. So we did our own calculations and did FEM analysis by Midas software. So Midas software, this bridge is, actually this is considered a long bridge of 240-meter bridge with elastomeric composite girders with elastomeric bearings. Next. So actually what happens with the long bridges, it is basically here the tractive effort is not that important, it is the braking force which is important. Braking force is applied by full train, all continuous over the bridges. In case of fish-plated track bridge, it is only the one span which is coming into picture. Here the entire bridge comes into picture. So that's why the braking force, as the calculation says, that it's 3,372 kilonewton, whereas the tractive force is 1,180 kilonewton. So that is important for long bridges. Second is challenge with the elastomeric bearings. Elastomeric bearings have very low stiffness. Their stiffness is basically governed by area of bearing, effective area of bearing divided by the total thickness of the elastomer multiplied by the modulus of shear modulus of the elastomeric. So the combined stiffness of pier and the bearing is like 1 upon K equals 1 upon Kp plus 1 upon Kb. So that is, it is lesser than that of the lowest stiffness. So that's why elastomeric bearings give low stiffness, they lead to higher rail stresses and higher displacement of the deck, which is an important parameter for ensuring stability of LWR on the bridge. So the limiting parameters are, as we know, I will not repeat them, these are the limiting parameters. Further analysis will be taken up by my colleague Sharad Agrawal.
Thank you, sir. Thank you, sir. This is the bridge, if we model in Midas, it looks like that. Here we can see that there are the girders which are 32 meter long and 30 meter long and 18 meter long. They are of different head. Height of the girder is also different, so that could also be captured in the Midas modeling. In the Midas modeling, the abutment is considered as a rigid structure. It will not have any yielding, and the pier, they are flexible, so there will be deformation of the pier. Then this particular case is a open foundation, so that we have taken as a fix on the soft rock, and the composite girder overall length has become 242.2 meter. So this is a case where we are having a very long bridge. Here elastomeric bearing is there, 60 kg rail, and approach we have taken 250 meter. So in all put together, I can say 250 meter on both the side approaches and roughly 250 meter of the bridge portion. So it has become 750 meter long, and 750 meter bridge portion and the track couple, I can say it is about 1000 meter long whole structure. And if you take a finite element modeling, even for 1 meter spacing, then I have to make 1000 elements, and accordingly the number of elements, node, elastic linkage and all other thing makes the problem very big. So such type of problem definitely cannot be solved on the models. Manually method is impossible, and because the behavior of this RSI is a non-linear in nature, it is non-linear in nature, so it will become very difficult to analyze manually. So when we have done this analysis, we can see this is the case with the elastomeric bearing, and in this what we have seen, the three parameters, the stresses, tensile stresses, compressive stress and the maximum support reaction, all these three are within range. But the longitudinal displacement and the relative displacement between the track and the bridge has become exceeding the parameters. So these are the graphs has been shown as a proof here. So when this is the case, I cannot accept this combination for the continuation of LWR. Now, with this result, we have some 5 possible scenarios which can be applied, like I discontinue the LWR, put the SEJs, that is the best easy possible thing, but we don't want that. Next is that I have to change the support condition of the girder, I can change the bearing type or increase the stiffness, or I can increase the stiffness of the pier, or I can increase the stiffness of the girder. So all these 4 options, if you look into that, so out of these 4, only option number 2 and 3, that is possible when we are having already a structure built. So in that case, if we change the bearing condition, like I make it fixed and free condition, then the support stiffness combined, I can see when it is fixed, then the combined stiffness is equivalent to the fixity of the pier, and for 18 meter it is 260 kilonewton per mm, and in case of 30.5 meter it is 41 kilonewton per mm. So that is the, if we are having a long pier, this is the effect we can see here, and this is the effect of the. So based on that, when we analyze, then we find even in this case the displacement has not been fully controlled. However, the compressive stress and rail also got increased. So this solution is also not a feasible. So we have to look further. Then we look another unit which is known as a shock transmission unit. And modeling of shock transmission unit straight away is not possible in VIDA software. For that we have to do a lot of I say dissection in the software, and somehow we have to put into that modeling. It is a difficult, intricate. Anyhow, when it has been done, so I need to tell you the main advantage of this shock transmission unit is when there is a slow force like thermal expansion, it doesn't transmit the force, it permits the expansion. And when there is a sudden or the shock is coming, it behaves like a rigid link, it permits the transfer of the force, but it does not allow any displacement. So what I am coming from here, I am coming a combination with the elastomeric bearing and shock transmission unit. Now it is becoming in between the condition of totally free fixed bearing and totally bearing like elastomeric. So this combination we tried, and here we can say, particularly using this, there is the limiting force can be applied. This shock transmission unit can have unlimited force, but if we go for that, then there will be a safety problem from the longitudinal stresses on the pier. So we have to limit whatever is the limiting capacity of the pier, so shock transmission unit should not transfer excessive force than that. So if we apply that limiting force, so that is how we are getting the different loops. So here I should say, this is the limiting force. This FL is the limiting force and Fn is the normal force, what is expected here. So we have to get the limiting force within the range. Then this is the various way of arrangement of the shock transmission unit. In this particular case, what we try to do, because what we have to limit is the displacement. So we try to share the displacement of all the spans together so that all the bearings are able to share the displacement and prevent it from that. So for that, we have to use the deck-to-deck connection, but all the force has to finally transfer to abutment, then we have to make the connection with the deck and abutment connection. Now this is the result here, and it is really heartening to see that the stresses are well within limit. Compressive has come 25 MPa, this tensile has come 25 MPa, and compressive has come 30 MPa. We are still having lot of limit. But the reaction at the support has increased 4,640 kilonewton. It is comparable to the earth pressure coming on the abutment. Now this is the case, it needs to be further examined and see whether it is adding to earth pressure or it is compensating the earth pressure, and when it is adding, whether the abutment is still safe or not. We don't have that data to analyze, but this needs to be examined, then only we can say yes, it is okay. And the displacement also comes well within the limit. So this is one of the potential options which we have to look for. Then the case comes, the next option what we are having is the sliding friction bearings, which we are normally using in this structure. And sliding friction bearing is simply depending upon whatever is the normal reaction coming on the bearing. Based on that, we can see what is its capacity. Yes, sir. Now, when we come that, there is a point how much displacement we can permit or take into that. So this displacement when we have taken, based on the research we have taken the displacement of 0.1 mm, and after that it will become dynamic displacement.
Please try to wind up shortly.
Just 1 minute, sir. It will become dynamic, and in that case, it will only move and it will not take further load. So that is how the reaction comes. When we analyze this thing, then we find out in this case, we find out all the parameters come very much within the limit. Yes, here we can see all the stresses, all the displacement, even the reaction at the abutment, reaction at the support, piers, everything has come very well within the limit. Now the question is that we have two options. Either we go for shock transmission unit with this elastomeric bearing, or we go for the sliding bearing. In case of sliding bearing, we have to change the sliding bearing, and in case of shock transmission unit, we have to provide it in addition to that. So these are the two possible solutions which has come out. Sir.
So these are the conclusions that we can try with the sliding friction bearings, which can give good results for, we can continue LWR through bridges. Another thing is that we need to do some revision of BS 114, because that condition put of thermal expansion and contraction giving the stiffness, that is not correct. And that another one is we need to have a ballast wall. Thank you very much.
Thank you, authors. And we'll be taking questions towards the end. So if you have any questions, you can write it down on the notepad, and any of our volunteers will help you with that. And you can pass it on to us, and towards the end, we'll be taking all the questions. Now, moving on to the third paper, we have regirdering of existing span number 28, 29, 30 up and down lines of Vadibandar Bridge on CSMR Kurla Harbour section in Mumbai Division. And the authors are Shri Nishit Kumar Mal, Deputy C Bridge Line Headquarters Central Railway, and Shri Vivek Kumar SSE Bridge Baikula Central Railway.
Good morning, respected chairman, co-chairman, and seniors and colleagues. I am Nishit Mal, senior in North Bhusawal, and I, along with my colleague Shri Vivek Kumar SSE Bridge Baikala, we will be presenting about the regirdering work we did in 2022-21, and it happens that the machinery has evolved so much, but it happens that due to site construction constraints, we are not able to deploy the machinery. So our paper is basically about this, where the machinery cannot be deployed and we have to work manually. So this is a Google image of the Sanders Road Vadibandar Viaduct. This is a very beautiful bridge composed of 44 spans, varying from 3.4 meter to 24.4 meter. Overall length is 527 meter. This was constructed in 1923. The steel was brought from Glasgow, England. It was earlier a ballasted deck bridge which was converted into steel channel sleeper in 1987. If you see here, there is a Sanders Road Bridge station. Under this, 4 lines from CST to Kalyan moves, and this station is over the harbour line, where it crosses the Vadibandar Viaduct and these 4 lines. The Vadibandar Yard and 4 lines. So this is the old photographs of the construction of this bridge. It is having a 6-degree curve and 1 in 34 gradient. So the history of the case is in 2010. During the inspection, it was found that 4 spans, span number 28, 29, 30 and 30 BP, are having huge section loss. And the work of regirdering was sanctioned at the cost of 1.36 crore in 2012. And the GAD was approved, and girders were fabricated as a welded plate girder in 2013 and 2014 by Central Engineering Workshop, Manmad. And due to the site peculiarities, after due deliberations, we came at a solution. And so it took a little time. And once we finalized working methodology. Then the TAD was approved in March 21, and consequently DCN for 81 days of blocks were sanctioned, and the work was executed from December 21 to March 22. So this is the GAD. We see these 4 spans, 28, 29, 30 and 30 BP. These were having the section loss. These were earlier riveted plate girder, which was converted into welded plate girder. So this is a table of comparison of older spans weight and new span weights. If you see the older weight, maximum it was 5.28 ton, and the smallest was 1.12 metric ton. While the new girders are 3.1 metric ton, and lowest was 0.84 metric ton. And the span varies from 11 meter was 29th span, 10 meter was 28th span, and 30th span was 7 meter, and 30 BP. BP basically stands for braced pier. So it was 3.4 meter length. So these are the regarding techniques which have used in Central Railway. Basically the easiest one is this, that we use a crane and remove the old girder and provide the new girder with the help of crane. The second one at the top is the famous Egaon viaduct regarding in 2009, where we use the portals to launch the underslung girders. And the bottommost is the replacement of rail bearers with the help of a portal beam and chain pulleys. In last 3 to 4 years, we have replaced around 210 rail bearers with the help of this technique. So we came at solution using after taking the cues from all the three methods. So the major challenges at these locations was there was no accessibility of any machinery. There was no accessibility for taking the girders to the site. All 4 lines are running just under the girders with OHEs connected to the girders. Along with this, there was 6-degree curve, 1 in 34 gradient, and there is the problem of high frequency of suburban trains. So first, we take up the inaccessibility of machinery. If you see here, the left side is, throughout the west side, this is Dongri area. We cannot bring any crane or something like that. Under the bridge, 4 lines of main lines crosses. Towards the east side, there is Wadi Bandar yard. So, and also the Sandus station is the India's first multi-layer station. It is constructed over the steel structure. So we could not take any machinery or like Farana or crane over this station for regirdering. So what we did, we designed a portal. Actually, what we thought is that the basic of any crane operation, it lifts an object and then it transports to somewhere, someplace. So we designed a portal beam consisting of ISMB 300 beams over the ISMB 200 beams, and 5-ton chain pulleys are connected for handling the girders, either for removing out or placing in position. So this is the photograph of portal. These are 2 ISMB 200 over a 4.1 meter height, and this is the ISM. Over top of this, we provided ISMB 300 of 8.8 meters. And if you see there are 2 chain pulleys connected to it, which each carrying a 5-ton capacity. The maximum weight of the girder is 5.28, so we designed it for 6-ton capacity. Another issue was the transportation of girders. Like we discussed earlier, there was no way we could bring the girders to the site either by road or rail. So at a distance of 400 meters, there is Wadi Bandar yard. There we brought the girders by road, and from there we loaded it with the help of crane over the dip lorries, and then we pushed it to the site. This is the photograph of loading of the girders with the help of a 100-ton capacity crane. Then it is loaded over the dip lorries, and then it is being pushed to the site for regirdering. Third major challenge was that there are 4 running lines just under the bridge. There was no working space. All the girders, rail bearers, are resting over the cross girders. So cross girders came to our rescue. We used the stiffness of existing cross girders to provide a working platform over this. If you see there, we provided a bracket of IS equal angle 130, 130 by 12 over a gusset of 500, 412, over which we provided ISMC 350 back-to-back channel, and over which we provided plywood of 18 mm thickness for the working platform. And additionally, we provided a insulation coating over these channels so that there is no induction. So this is the photographs of that working platform. We used the existing stiffeners of the cross girders, and then we placed the ISMC 350 back to back, over which we provided the plywood. The fourth problem was the easiest solution, regarding it where the girders are simply supported. But here it was that in the last two spans, 30 and 30 BP, the end connections are fixed connection. So providing a riveted with match marking, it was very difficult. So what we did in pre-block activities, we removed the cover plates and we did the match marking at position. This is the, if you see, this is the 30 number span, and then it is 30 BP. 30 span is one side simply supported, one end is fixed, and 30 BP is both in fixed connections. So execution. During pre-block activities, what we did, we removed all the SNT cables and shifted it to the platform girders, converted all the riveted joints into turn bolts, and then we provided the working platform over the running lines and connected the suspenders of OHE to the ISMC 350 back to back. And there was a stool under the simply supported girders, which were connected to the cross girder with the help of bolts, these were so much corroded that we had to, during first block we were actually, the block was fired due to that. So what we did, during pre-block activity, we removed the bolts and provided with turn bolts there too. So this is the methodology. First we erected the portals, then we removed the first girder and placed it over the dip lorry, and then second girder is removed and placed over the dip lorry, and it is transported to the loading unloading point, and then next girder is brought by similar method and it is launched in position. Then second girder is launched, and after that we provided the bracings and footpath. So we will deal with details. So this is the erection of that ISMB 300 over the ISMB 200 for providing the portals. Then after the erection, the girders are lifted. Girders are lifted, and then these are placed over the dip lorries. Then these are transported to the unloading site. And similar fashion, we brought the new girders and then we launched it. After that, we provided all the bracings and with the help of turn bolts, and track is lowered, and all the fittings are recouped to provide to restore the traffic. Post-block activities. After post-block, we provided all the turn bolt with riveted connections, and we provided the footpath and decking plates. Then we dismantled the temporary staging and used in the next spans, and all the OHE connections are provided and restored. So challenges faced, first was the stools of girder. These are the stool. These are very corroded, and we could not find the bolts and the stool. It was so much corroded that we could not remove it. So what we did, we cut the edges of these the stools to remove it. And the next issue was the weight of portal column was heavy. So what we did, we converted into two columns. We provided same base plate which was connected to the cross girder. Then the fixed connections, when we opened it, it was found that the gussets are perforated. So during the work, we strengthened it by providing cover plates. And dusting of girder during launch. Another issue was that during launching of fixed-in connection, there was no support to rest the girders. So for that, we provided a brackets of 150 back-to-back angles.
Please try to wind up your
Thank you,
piece
sir.
now. Thank you.
Thank you, sir.
Thank you, authors. Let's give them a huge round of applause.
Thank you, sir.
And we have received some questions for all of you, so we will be distributing those questions to all the authors towards the end. Let's have the next and the fourth paper, that is cantilever erection of 145 meters open web girder of important bridge number 340 in connection with Ahiran Sujnipara doubling in Malda division of Eastern Railway. And the authors are Shri Anil Kumar, Chief Engineer Construction, Eastern Railway; Shri Hemant Kumar, Deputy Chief Engineer Construction, Bhagalpur, Eastern Railway; Shri Ranjit Kumar, SSE, Bridge Construction, Howrah, Eastern Railway. Best of luck, gentlemen. Over to you.
Good morning, Chairman sir, Co-Chairman sir, other senior officers and dear friends. I'm Anil Kumar and Deputy Chief Engineer, Bhagalpur, Mr. Hemant Kumar is with me. In this paper, we will be discussing strictly erection scheme for the 145 meter, which is central span of this bridge. This bridge 340, as told, it is in Malda division in Sujnipara iron section, and it consists of 3 spans. Both approach spans are 125 meter and central span is 145 meter. For an idea, I will give some salient features of the project also, but 125 meter both span are about 1200 metric ton and the central span is about 1600 metric ton weighing. In this method, we had used the cantilever method with taking use of approach span as cantilever, cantilever span, and the approach span as what is called that? Anchor span. We had calculated the moment also, and accordingly we had used the cantilever, though it was not required as because 1200 metric ton was weight for the approach span, and we had used the erection from both end, P1 and P2, so it was about 800 metric ton the cantilever load was coming for the central span. The main crux of the erection scheme is basically designing of the false member used for the cantilever erection members and its importance and specification of the material used for the members, false members. And other important is the sequence of erection, which is also important for the safety of the erection scheme. Thereafter, the dismantling of temporary and false work. Again, the sequence-wise, it has to be dismantled. That is also much more important in view of safety, since it is a very big span and underwater, the running water is there. Finally, the alignment and cross level at every erection, and thereafter, after the connection at the midpoint, it was done after the dismantling of false work. Camber was checking both in self-weight condition and under superimposed dead load also. So after gaining experience, we will be discussing the precautions to be adopted for cantilever erection and thereafter conclusion and recommendation. This is the overlay. This is the salient feature. Foundation is 9 meter diameter, 2 meter staining thickness, and curve depth is 3.7 service structure. Length of cross girder is 8.5 meter, height of girder is 17 meter, and bearing we have used the spherical bearing. The structural steel, what I said, specification was most important. In this case, we used MS plate of E250B O grade and E410B O grade for hollow and circular section, which are basically for bracings. Main top cutout, main members were face-to-face C type, beveled deep welding, and design speed is 160 kmph for passenger train. This is the proposed bridge alignment which is coming in the state, that is the right side of the screen. But though it's in the skew, it was basically due to we have used the meter gauge land available there, and that was it came in the skew. No land acquisition was done for this project. This is a schematic diagram. Gross weight, the central span told it's 1600 metric ton. The reason for going for the sequential cantilever erection that was done from both end of the 125 meter is mainly due to the inland water way, which is the feeder canal of the Farakka barrage, which is hardly 2 to 4 kilometers upstream. Ganga bridge is there, Farakka dam is also there. So we didn't want to go for conventional method of using the tracer method, where we had to block the central span by putting liner pile foundation, because due to load in conventional method we had calculated the piling also. A piling group of nine group with metal liner has to be used. So we avoided that portion, and that would have also time consuming. Normally with pile foundation and using tracer dismantling, it takes 10 to 12 months. So, but in this case we could complete in 3.5 months. These are the false work type and specification which were used for connecting the anchor span and the cantilever span. Anchor span, what I told, 125 meter, we use the approach spans. These are extension piece, link pin, bearing slab, hanger plate. These were used as false member for sequential erection of the each nodal members. This is the main feature. This is the span arrangement at erection stage. Here we can see the top chords where this is the anchor span 125 meter and that is the cantilever span 145 meter. From both ends, P1, this is a P1 picture. The similar picture is there at P2 side. From both ends we started simultaneously, and at the total nodal point in the central span is 20 node members. So 10 members were taken from this end and 10 members were taken from that end. For connection of that anchor span with the cantilever span, we use the extension plate that is at the top chord, which is coming in tension part. For taking compression method, for considering the compression force that is used at the bottom chord, we use the slide, bearing plate which is shown at the buffer slab and bearing plate which is shown at the corner, bottom corner. It was taking care of compression force. So HFG boards were there used, and in the central span about 1.54 lakhs HSFG boards were used, and at the approach span, each span was having about 1.16 lakhs HSFG boards. So the whole crux of the erection is basically the designing and adequacy of the false member used in the erection, and the second most important, how we go ahead, sequential erection of the members. For just an idea, we calculated from start the basic force, including wind force also it was calculated, which was coming on the link member, that is on the top chord. And at the bottom chord, also buffer slab, it was coming in the compression. We use the steel grease coat, taking the, details are there, axial, tensile and bending stresses are there. Based on that force and stresses, we had calculated the members used in the extension plate. Now my deputy C will discuss the detail how sequential erection was done, and in short the design specification also.
Good morning, sir. Now myself Hemant, I am now going to discuss how we have designed the member. In past we have seen that is two connections, that is one is extension plate and one is bottom is buffer slab. The top member is in tension and bottom member is in compression. So accordingly the start force we have calculated the force in basics, and we have also considered wind forces also, because in that region around in the month of July the wind forces around 40 to 50 kmph is coming, which is also known as Kal Baisakhi. And for the material we have used in the specification, whether it is special type of steel, that is we have already mentioned, that is C55. C55 is a special type of wrought steel having carbon percentage 0.6 to 0.7% and manganese having 0.6 to 0.9%. And this member we have used by using USFD testings, that is link pin, bearing slab and buffer slabs. All these are wrought steel. In the design, now we are going to discuss extension plate. So we have considered two forces, basic forces and wind forces. And we know we have already calculated the value of wind forces, and accordingly we have provided the stresses value also. that is permissible stresses and area we have calculated. Based on that area, we have assumed that section, that is roughly 1242 centimeter square area. Now, for deduction, we have also, for net area, we have provided the deductions of holes, and accordingly, we have checked whatever the load are coming, and we have multiplied by that area into permissible stress of material, and we have checked that our load is coming, whatever we have calculated load, which is, and whatever we have calculated load, and whatever load calculated from stat force. So our load is higher, hence our design is safe. Now we are using wind forces as per IRS steel bridge code clause. So we need 33% higher area across the pinhole. So accordingly, as for wind forces, in our cases, our wind forces is 1,030 metric ton. Sir,
Please try to wind up in 1 minute, please.
Sir, 1 minute, sir. And accordingly, we have calculated the pinhole area. So, okay, sir. Sir, accordingly, we have calculated the pinhole area. Now we have whatever area we have provided, we have checked with deduction of net hole. So our area provided is higher than the theoretical area. Now design of link pin. This is the most important aspect, because mainly the failure of the erection scheme happens at this stage, whether it is in tension member. So link pin, we have checked for shears, we have checked for bendings, and we check for bearing also. So in our cases, all the members are safe. Next. Now we have also designed for buffer slab, which is the forces due to erections in bottom horizontal thrust, that is compression forces are coming. So accordingly, we have designed for the buffer slab. If you see the scheme, here we have seen that total distance between center to center bearing is 2,200 mm, and the projection beyond the center line of bearing is 700 mm. So by arithmetically, we have provided 500 mm thick width of bearing slab. Now, as per, because if you see the diagram of the bearing slab, it is not perfect cuboid, it is some circular shape. Because of why we have provided circular shape, to provide the rotation due to deflection and erections. So as per IRS steel bridge code, we have provided the diameter, theoretical diameter is 1500 mm, but we have provided theoretical diameter 3200 mm. Accordingly, we have checked buffer forces, we have checked for bearing forces, and our all forces are safe. Next, this is hanging device. So in hanging device, we have calculated whatever the load are coming after the erection of first panel. With the help of triangulated, we have the triangle calculation. Whatever the load are coming, we have provided 2 number of hanging device. So we have multiplied by the 2 numbers. So we have total hangers capacity we have calculated with the 2 number of ropes. Now we are checking of cartilage. Because our restoring moment because our anchor span weight is roughly around 11,015 ton, and the restoring moment is very higher than the overturning moment, hence no need of cartilage. Now these are the methodology of erection. In the methodology of erection, first we will erect the anchor spans. After that anchor spans, we will check the alignment and lining leveling with the center line of proposed bridge. We will connect the false member. After fixing false member, we will connect temporary bearing. After temporary bearings, we will start the evenly distributed panel erections. And because we have no scope of further revision of camber, so we have provided link shortening and camber due to self load and superimposed dead load. We are providing very initial from the L0 first panel, and this is the sequential erection, because we have to follow the sequence of erections, how we have to going to erect, like bottom chord, stringers, verticals, top laterals, bracings, etc. So we have to follow that sequential erection. After erections, we have to 100% tightening SHFG bolt, because before going to the next erection. Now the most challenging task is the connection of the mid plate, because we don't know whether our alignment is going correct or not. Although we have designed it, but the main crux of the story is how we are going to connect the mid span with the 4 number of elevation gusset plate. 1 elevation gusset plate is the bottom chord, 2 number elevation gusset plate is the mid level, and top chord at the gusset plate. And third, After the connection, we have to remove all the false work member. We have to disconnect all the temporary members. After we have to checking, we have to do alignment correction with the help of traversing base. Other miscellaneous works like H-beam, running rail, guardrail, walkway etc. In final, after alignment correction, bearing placing, we have to check camber in dead load and superimposed conditions. Now this is the sequence of erection. If you see that here we have first erected the anchor span and we have fixed the extension
Please
plate.
try to finish it off in next 2 minutes.
Sir, last 1 minute, sir. So we have fixed the extension plate at the C section of the anchor span. From there, extension plate there. After that, we have placed after cantilever crane at the top chord of the anchor spans. From there, we have connected the cross girder at the bottom, L0, L20. And after that cross girder, with the help of cross girder and with the help of hanging device, we have connected bottom cord. With the help of bottom cord, we have connected cross girder of the preceding panels, that is L1 and L19, followed by the stringers, followed by bottom lateral bracings and verticals, diagonals, temporary struts, verticals, and after that top cord. After connection of top cord, we have connected the extension piece with the anchor spans and we have fixed with the link pin. After that, now the top track has been connected to the preceding panels and feeding track has been connected with the stringer levels. This is the erection scheme. This is the erection, how it has happened. The same sequence we have to follow throughout the entire span. And the most important thing that before proceeding with the other panels, we have to ensure that 100% tightening and torquing has been ensured or not. If it is not, we should not go for the further reaction. So now how we have connected in the mid span, because total we have weight of 1600 metric ton and 20 number panels. So each panel average 80 ton load are coming. So at each node point at elevation gusset place 20 ton loads are coming. So we have provided 30% of drift and 70% HSFG. After that connection, we have also removed that 30% drift with the HSFG bolt one by one and diagonally. This is the connection how we have done in the mid span. After that connection, we have dismantled. We have removed the cantilever crane. We have with the help of lifting, with the help of traversing base, we have lifting the jack. We have removed the false work like extension piece, link pin. All temporary arrangements were replaced. Whether we have fixed with turn and fitted bolts, we have replaced with HSFG bolts. Lining leveling were checked and camber were made. Our camber variation was 0.38% to 22.5%. So what are the precautions we have to adopt in case? That is, apart from physical and chemical test, we have to USFD testing of the plate. The most important aspects, we never used to do USFD testing of link pin and buffer slab and so, because it is a wrought steel. There is no specific guideline in the Indian code. We have followed the ASTM code. Complete tightening and torquing of HSFG bolt, turn and fitted bolts, whatever we are using, it must not have any tolerances. Any tolerances will cause any secondary stresses. And the most important crux also is the weight of the anchor span must be more than the cantilever spans reactions. That is, in our case, the reaction at the support is 8059 metric ton, where the weight of anchor span is 1150. Hence, our erection is safe. That is, what are the conclusions and recommendations based on the erection scheme? That quality aspect of the false member should be the highest priority, even more than the main structural members. Sequence of erection must be strictly followed, 100% tightening torquing must be ensured, and the simultaneous erection will be done in the same pace. It should not be prolonged. Thank you.
Thank you, authors. So while we are going ahead with the last paper, before we break for tea, we have one more paper to go, and we request everybody to please take your seats. I would request all the authors to please come and join us on this side. From the previous 4 papers, I will be giving you the questions after 5 minutes, so you can go through that while the 5th paper is being presented. So the 5th paper is Digital OWG Bridge Inspection Using Modern Technology like 3D Photogrammetry, Drone LiDAR and Terrestrial LiDAR Scan, if I am saying it right. And the authors are Shri Achal Jain, CPD TMS Northern Railway, Shri Anisur Rahman, CETMS Northern Railway, Shri Dinesh Kumar Sharma, GM CEP4 CRIS. And the presenter is
Mr. Anisur Rahman.
Mr. Anisur Rahman is going to be presenting the paper. Can we also have all the other authors to kindly come and join us on the dais? There are chairs out there. We'll be distributing the questions to you. Whichever questions are towards you, you can go for it and prepare yourself.
Thank you
Over to
very
you,
much.
sir.
Thank you very much. Respected chair, co-chair, senior officials, and my colleagues. Actually, I will be presenting a paper on some of the POCs which we have done to corroborate various findings, whether we can use digital methods, indirect methods of inspection of important bridges, and we have found that it is going to work if we persevere. So as you know, we have 1,50,000 bridges. Out of that, 700 are important and 12,000 are major. And currently the inspection are being carried out by mobile inspection units, ladders, ropes, requiring operational closures and blockage of routes. So these inspections are logistically very complex in nature, and some of the structures are very difficult to inspect because of they might be lying on a high flying water or may be lying on a high altitude. So actually there have been certain guidelines in the past also for using drones of inspection, but basically they covered only the visual part of it, like photographs and videos. So advancement of drone-based photogrammetry and LiDAR point cloud technology have created possibility to adopt indirect inspection of railway bridges, particularly the important bridges which are not accessible. And if it is integrated with the web-based bridge management system, and the legacy data is also compared, past data, then it can form a very good comparison and decision making. It can facilitate the decision making process for deciding the health of the bridges. So earlier RDSO issued guidelines, BS 129, which was basically for use of drone for inspection of inaccessible areas of bridges. It covered, its scope was limited. We have conducted 2 POCs using LiDAR point cloud technology. LiDAR is basically light emission and detection and ranging. Basically it sends a pulse and it receives back the pulse after it hits the surface which it tends to, and there are the clouds are captured. So what it will have, basically it will, apart from visual checking, it will allow measurement of schedule of dimensions also, including the complex one, like you can measure the if there is the bridge frame distortion is there, or member distortion is there, and there are other parameters also which are very much required for the assessing the health of the bridges. So what are the various technologies that were used in the past? You can see in the RDSO guideline UAV drones, I told you earlier. RTK, real-time kinetic drones were were used basically. They actually follow the course station developed by Survey of India. Course is continuously operating reference frames. So they are very positionally very accurate, and they are able to get the data very quickly and very with a high precision. And LiDAR basically brings positional accuracy, which is very high fidelity required for high fidelity measurements. So what is the basically the output? Output is basically 4K quality video in case of the videos, drone inspection, and here a very accurate, dynamically accurate 3D model is generated from point cloud, which has more detail than digital surface model. So what it helps in, basically the inner bridge dimension can be measured, overall dimension can be measured, cross-sectional and other can also be measured. The software used basically is Bentley's context capture and Autodesk Recap and Pix4D. These are the softwares basically available for the, Bentley is a pioneer in this field. So this software basically can process both photos and LiDAR point cloud data set. It is very fast. It has overlays, scales, so it helps in measuring basically, because we prepare a very 3D CAD model which allows us to do all kind of measurements. So what are the results basically? In case of drone inspection, we have photos, videos, and a 3D reality model which is approximate. So that is for basically visual inspection. Here a high fidelity 3D model, CAD model is generated. So all SOD dimensions and distortion, bearing heights, L section, everything is measured. So you can slice this through, you can cross-section laterally, longitudinally, every way. Our dimension can be measured with and compared with original drawings as well in-field drawings, in-field measurements. So this is the Faro LiDAR equipment. This is the basically 3D geometry model using the photogrammetry by the drone data. This is LiDAR point cloud data. This is a merged CAD model, and I will show a brief video how the concept actually the models are generated by using the data. Yes, this is the 3D photogrammetry model. So this is a point cloud model using the point cloud data obtained by the LiDAR. We are using terrestrial LiDAR as well drone mounted LiDAR also, because some of the areas we cannot use terrestrial LiDAR, which has a range, deficiency, because up to 150 meter we can use that. So drone mounted LiDAR is also being used. So this is a model wherein you can use, do the, all the cross sectioning. In fact, including focus to a particular area of interest, which basically we want to, get idea in detail. And so because of the model, which is a CAD model, this is slicing, vertical slicing. You can do longitudinal slicing also. And once it is done, you can measure the dimensions. So under frame, the bearing areas, all the areas we can look into. This is the measurement using a normal CAD drawing type of. So it allows all kind of, processing and decision making by having the complex measurements, which are not particularly possible in case of manual or as well as the other conventional methods. This is a dimensional fidelity test measurement, like you can have the diagonals to know whether it is twisted or this is a diagonal measurement to know the frame assembly distortion. So it's very simple, otherwise it is very complex. Measuring this diagonal is hell of a job in case of manual using ladders and other scaffoldings and so many other equipments, specialized equipments. So you can know from bed block to bottom of the girder, all such kind of measurements can be taken. So before embarking on the POC, you need to define a certain key particular area of interest, and those areas basically we want to examine. So those are the protection works, abutments, piers, bed blocks, bearing and vicinity, lateral bracing, sleeper seats, flooring arrangement, gusset connection, top lateral bracing, top boom, bridge works. So high resolution photos, what they help is they can be viewed from multiple angles and lies in deficiency of for any deficiency or failure. Deficiency can be like missing rivets, loose rivets, taking cue from rusting around them, hit marks, failure of masonry structures, flash marks, OHE, bearing. This is the visual inspection. You can see here, there is a rivet missing there. Then you have end raker bearings. the rivets on those areas. So there is a rusting, you can see here. All kind of good quality, high resolution photographs can be used to look into the various areas of bearings from all corners, all sides. So it is possible sitting at the home. Basically, it requires 1 or 2 days of field work, and all the other things are done at the in the office. So you can see the measurements I have compared. As per our DSO drawing, you can see 47850. 47840 is the manually measured, and then you can see digital measure 47848. So it is very much comparable, and similarly, you can see the height catenary where the contact bar touches. That height is also matching 5340 and 5177 and 580 as per our DSO drawing. So all the readings these are the camber readings. You can see the legacy data is also compared, and it was physically verified in August 22 also. So camber results are also within the limit up to plus minus 5 mm. So which is really heartening. You can see the diagonals measurement. You can see the D1 is 778, D2 is 775. So although we are not using it manually, we cannot measure it manually. Here we can measure and compare, and you can see the difference is very within the prescribed limit. Then there was second PUC also done. Here we used basically a terrestrial lidar and drone lidar. So a model was generated after getting the lidar data, and you can see here also I have compared the measurements from the second POC. As per design, you can see 32460, and there is terrestrial lidar 32469, drone lidar 32478. It's slightly higher, but it's also very much comparable and within the limit. Then you can see the other measurements also, including camber measurements. All these are found to be within the limit and within minus 5 millimeter accuracy. And this member distortion is also measured by measuring the D1 and D2 in the office, and you can see it is also very much comparable. So far we are doing another 2 POCs also. The result will also be compared, and we can see. So what are the major benefits of this? Basically, measurement of all parameters required for ascertaining the health of a bridge can be known very accurately within the prescribed limit. Plus minus 5 mm is the accuracy. Actually, digital method allows quantitative analysis of important parameters of health of a bridge that are not possible by conventional manual means. Advantages are what? Basically, flexibility is there. You have repeatability. You can view any number of times. For manual measurements, you have to again visit the site. Here, you are not required to do that. So here it is very simple. You can review all the measurement. These are realistic, and virtual bridge library can be built, which can be a reference point for future measurements. Level of details of high resolution images are sufficient for visually ascertaining the defects or otherwise. Parts of bridge can also be scanned if you required. You are not required to scan all the. If there is a doubt regarding particular span, you can go for that also. This will minimize requirement of a specialized technical manpower, and the inspection may be carried out in difficult terrain, fast-flowing rivers, etc. So ISO guideline, revised guideline have been issued recently, and work has also been sanctioned. Actually, as per PUC, we see that the cost is around 4 lakh for 100 meter, two span of 150 feet. So, but later on it is going to be very cheaper, because once so many computers develop and the players are more. So, what are going to be futuristic benefits? Because we can use image analytics, machine learning, and other imaging tools leading to automation of measurements. You can define a criteria, and the measurement will be automated. Automatic failure detection, automatic adjustment of bridge health index, system recommendation of inspection frequency, that is condition-based measurement maintenance. Generation of maintenance job cost is possible. Failure prediction, predictive maintenance can be done. Long-term bridge health analysis can also be done by comparing past year's data. So, thank you very much. Thank you.
Thank you, sir. So I would request the chairman and the co-chairman to kindly summarize.
Now I request my colleague Sri Alok Kansalji to to give his views, observations. Thank you.
Good morning to all of you. Let me first, on the onset, compliment the authors who have tried to present their topics in a lucid way. Before that, I would like to say a few words. See, the purpose of holding such conference or seminars is to exchange the knowledge among the various participants right up to grassroots level in a manner that which is easily grasped by them. So my suggestion would be that the too much of discussions on the design parts leading to the longer slides and presentations will not serve the purpose more. Coming to the paper number 1, the author has tried to briefly give us the brief development of the LWRs, CWRs over the Indian Railways and the technical innovations which have been done on Western Railway. The lucid presentation also gave the ideas of how they laid the CWR through the yards. One of the irritants mentioned by them was the glue joints, which in my opinion should be get rid of once we have the DAC in the automatic block signaling, which is going to come in a big way on the Indian Railways for 2 reasons, for the safety and then the mobility of the sections. But the food for thought would be that so far we have been doing the rail brakes or the buckling by manual patrollings only. So the RDSO and our ministry have to look forward for finding out the ways and means to how to have the best way of the stress measurements in the CWRs, which are going to be through the yards, and the stresses which generate during the extreme winters and the summers need to be tackled in a very safe way. The paper number 2 was covered by the Irisane on the LWR on the bridges. They have mentioned that they have submitted some proposals to RDSO for continuation of the LWRs and CWRs on the bridges, which needs to be examined. Then they gave a lot of technical details and subjects about the forces which come on the bridges while the train is moving on the bridges, and the temperature and the various forces which will come on the way after they lay the LWRs, CWRs. And a brief touch on the Midas remodeling was given by them. Professor Agrawal also tried to explain the mechanism of transfer of various forces on the structures through the STUs versus the displacements noticed or observed, and then finally concluded by the recommendations. The paper number 3 talks about the regirdering of the rail flyover in Mumbai suburban section, and I just observed that the work was sanctioned in 2012 but finally executed after 10 years in 2021-22. There are some several site constraints which they noticed, which is typical of Mumbai suburban sections, and the challenges faced and the solutions given by them. In fact, in 2019, there were a third-party audit done on the various ROBs and FOBs in all over Indian Railways, and we found that a lot of ROBs in Mumbai suburban sections needed replacements. And many of them have been replaced, and quite a few of them are under replacement. I would suggest that the documentation part, which was suggested yesterday also by the chairmen, that it needs to be done in a very, very lucid way, either by Irisane or by a body which can be used for a case studies in the future times to come. Followed by the paper number 4, the cantilever erection of the 145 meter OWG, which was earlier on a skewed angle of 45 degrees, which was later on realigned to a straight one. This is a good innovation and then good technique used by them. They discussed again the design part in a lot of details, in number of slides, and then sequencing and the time frame and the precautions. Friends, I will only say that design may be the best done in the offices, but the field execution becomes very, very important when it comes for the launching part of the things. Recently, we must have all heard that lot of accidents have happened during the launching of the various girders, both in the railways and the state government's projects also. So we need to have a very, some coverage of the safety which should be taken during launching of girders, which was using the false work, and the technical supervision have to be done under the competent supervisors also. Lastly, the most important one was the bridge inspections part. 1.5 lakh number of bridges, out of which about more than 700 are important bridges. Number of modern techniques have been issued, policies have been issued by the Indian Ministry of Railways and the RDSO. And one of them was discussed today in this paper, which was dealt upon, and the concept was proof of concept, the POC, using the 3D modeling by LIDAR techniques, which was giving various measurements in the various members of the girder or the bridge proper. Also, they mentioned, you use the word health of the bridge. You see, when we all are young and we start aging, we need to take care of the health of our body. So are the bridges. When they start aging, although total life is 60 years, but then when they start aging, and then the techniques of the inspections are not modern, so it leads to a untimely death of the bridge also. And then we start doing regirdering and rehabilitation and all major repairs of the bridges. In this again, the designing of the structure should also take care of the lifetime maintenance requirements of the structure, like the use of new modern materials, stainless steel and high strength steels, and how to facilitate the inspecting authorities in the future times to come, because the bridges are located as high as Chenab Bridge, the highest in the world. And I am told that they have engaged a very qualified technical agency to monitor the inspections and the subsequent maintenance activities. Similarly, we need to find out some solutions, and for that the inspections requirements become minimum and maintenance requirements become minimum. Like long life paint schemes, which are already proven in the world over, but then we need to finalize in our country also on Indian Railways. All the time, I was just observing that the authors have tried to bring about the various aspects of in their papers, the technical parts, the designing parts, the problems, constraints, and the solutions in the field. And this was a very wide coverage in this portion. Now I hand over the mic to my chairman, sir.
So, thank you so much, Co-Chairman. Thank you so much for the wonderful insights and everything which you pointed out. Now, Chairman, sir, has requested that he would like to summarize after everybody's questions, once we do the Q&A. So, we would request all the authors to please come and join us on the stage. And once all the Q&A is done, respected Chairman would like to summarize that as well. So paper one, over to you.
Yeah, paper one. So we have received overall 5 questions. One I have already answered. Balance 4. A very important question from Mr. V. Narayan, ex-Chief Engineer, Northern Railway. As CWR are through turnout, how the de-stressing of turnouts are done? Very important. Actually, in our paper, we wanted to highlight only one aspect. A correct laying and the sequence of operation is very, very important if we want to behave our CWR in the way we want to. And therefore, there is an elaborate procedure. I had shown one sketch in the presentation which says that how we should weld the joints in the turnout portion. So when we are welding the switch portion, all the fastenings in the switch portions are kept intact and the other portions are loosened. When we are welding joints in the crossing portion, then the switch portion fastenings are loosened and crossing portion fastenings are tightened. When we are in fact converting portion between 2 point crossings, which is not LWR, when we are doing that, then entire portion is made rail free, and then after welding all the joints in between, then we weld the joints adjacent to the turnouts. So this sequence is very, very important if we want to have the CWR to behave properly. Now, balance 3 questions I would ask my co-author, Mr. Chirag and Abuzar, to answer.
Good morning, everyone. Today I'll be replying to the questions asked by Rajiv sir, CTER. That is, in which method currently we are using for stress-free temperature, and the second question is of measurement of stress-free temperature in IR, as there is no tool for the same, and is there any provision for this, which is asked by AEN DGR, Mr. Pramit. Currently, actually, there are no direct methods for calculation for measurement of stress-free temperature. However, we have indirect methods which we are using till now, such as measurement of gaps in SEJs. Secondly, we provide creep posts in the LWRs every 1 kilometer to check the movement of the LWR. In case of the CWR, we have different, we have first the ACD, which shows us how much we have, what is the temperature, what is the movement in the ACD, shows us how much there is a stress in the rail. Secondly, we have provided creep posts at 5 locations, which again gives us an indirect approach to the stresses in the rail. Currently, no credible stress-free temperature measurement device is available. There is one device which we saw in the exhibition also of the verse, which will be used in NER on a trial basis. There are some countries where stress-free temperature is being monitored on a continuous basis, and such methods and such devices are required in the near future for correct measurement of CWR and for proper maintenance practices. Thank you.
Respected dignitaries and all senior officers, the question which I have received is, have you faced any ACD breakages in Western Railway? And adding to that, have you made any changes in ACD design? So till now, the first CWR which we laid in down road has faced temperatures from 15 degrees to 58 degrees. As of now, we haven't faced any ACD breakage. The idea is we are closely monitoring the gaps at the ACDs. Till now, any ACD has been jammed. So the idea is, the indirect way of measurement is, if the gaps remaining at ACDs at extreme temperatures are 1 or 2 mm, there are still gaps are remaining. So right as of now, we haven't faced any ACD breakages. The bottom line is, we need to see the tow loads. The indirect measurement for us is the measurement of tow load if we are observing excessive gaps or in case of jamming of ACD. So we need to monitor the tow load in the approaches, in the temporary breathing length of the point and crossing zone. And another is, have you made any changes in ACD design? As of now, we haven't made any changes. As per the RDSO specifications mentioned in CT48, those ACDs were supplied to us through headquarters, and the same cast anti-grip devices we have used in our CWR. Thank you.
So the first question is from Mr. MP Singh. When the zero tow load fastenings are there, then movement of girder shall not come into any additional force in the rail. So why not continue LWR on the bridges with bearings? This crux of this is that as we have rail-free fastenings on the bridges, then there is a limitation of LWR due to gap at fracture. So gap at fracture should not be more than 50 millimeter. So that is limiting the length of LWR on the bridges. That is severe restriction. 11 meter on zone 4 and 27 millimeter in zone 1. Next question is from H.K. Jaggi sir. As the study presented applicable for all kinds of foundations irrespective of foundations such as substructure. Sir, this is applicable for each and every substructure is different. So each and every fixture, the stiffnesses have to be determined for each and every substructure. So it cannot be universally applicable. As RSI analysis has to be done for each and every bridge. There is no option. Sir, another question is from Mr. Mandul Mathur. What were the foundation of the bridge? Analyze open, deep foundation with decrease of stiffness. What solution? Sir, this is the open foundation founded on rock foundation. For deep foundation also we can analyze, there's no issue. But pile foundation generally give lesser stiffness compared to well and open foundation. Do you think that there is a need to relax the limit of deck displacement, as these are after all serviceability criteria limits, not the strength? Sir, these limits have been laid down on the basis of stability, LWR, the buckling criteria. So if the displacement more, there are chances of ballast getting disturbed. That is why such a severe limitations have been laid down. In case of ballastless tracks, like in USBRL, we can certainly think of that. But not on Indian Railway, where we have ballasted bridges. There we cannot do that. Another question is, how does the height of pier and the length of girder affect RSI analysis? So if the height is more, the stiffness will be less. Stiffness is basically force required to make unit displacement at the top of the pier, top of the bearing. So that is why the taller the pier, lesser is the stiffness. Another question is from Mr. Swapnil Chaurasia. As per the Railway Board letter, field trial for LWR on ballasted deck bridges and steel bridges, the span is limited. Ballasted deck so and so 24 mm, total length 110. So in this connection, I want to say that this trial order was issued in 2017. The committee of PHOD committee gave the recommendation, based on that it was given. The understanding was that the limitation was because of the UIC code provides the interaction chart up to 110 millimeter spans only. So that is why that limitation. Now this is no more required because we have got softwares which can do multiple spans any number of times. Structural softwares are there. So this proposal has been submitted by RDSO to Railway Board to relax this limit. I think we will have a order on that. Is your study much longer span are found to be feasible with modification in bearing, and why such highly limiting criteria are applied? So criteria we have already discussed. Longer spans, if the parameters are within limits, we can go for longer span. There is no issue. Thank you very much.
Sir, we received a question from Sri S.K. Bandopadhyay, AXIN Construction, East Coast Railway. First question was about the block duration. Total 8 mega blocks of 5 hours each was taken on Harbour line while the main lines were still running, and we did the preparatory work in 73 night blocks. Another question is the fixing of bearing. We provided flat bearing in the simply supported girders, and it was provided during the blocks, and we provided guide strip and locking strip with these two. And third question is whether these turn bolts have been replaced by HSFG bolt. No, we provided the 22 mm rivets instead of HSFG bolt because it was designed like so. Thank you.
Sir, first question is from Sri V.K. Srivastava, PCE Metro. It is, where was trial assembly done for this bridge? This is related with erection of 145 meter span bridge. Sir, the trial assembly was done for 125 meter span approach spans at the workshop, which is very near to the site, near Navdeep Dham. And for central span, that is 145 meter, it is at Calcutta, at Mr. Sarahi workshop. At what stage final HSFG bolts were put? Sir, during erection of every panel of central span 145 meter, before going ahead of the second panel, we ensured that 100% HSFG bolt were put every panel wise, sir. The other question is, sir, can we push oblique pull such girders by which and pulley arrangements? Sir, in our case, as we discussed that there was constraint for the feeder canal where we could not put the trestle at the nodal point for making arrangement for the launching nose, and for such heavy girder which weighs for about 1600 metric ton, we had to design for launching pad also, and counterweight will be much more. and it has to be done from one end. So I do not recommend, though I have done this type of arrangement for 61 meter span. Sir, other question is from Sri H.K. Jaggi, sir, ex-GM NFR. How was camber measured and permitted during erection stage? Sir, during, though we could not cover in our slide, we had discussed in our technical paper that we had considered the camber in 3 parts during erection, that is in link shortening part. We had considered erection about 53 mm due to deflection and 67.5 mm it is for due to camber, that is a difference between manufactured length and nominal length. And another 67 mm length shortening due to jag, it is there in technical paper. So against about 115 mm desired camber, we put 190 mm camber during the erection stage. So in that way we could achieve the final what we have got, and that camber is there in the paper also. Next question, sir, how did the actual camber compared with the design camber? This is, sir, during field erection, we have been very, strict for measurement of erection. Center line of girder of each panel were marked, and every corner of the bottom chord we were taking the camber measurement, and we were comparing with the X, Y, and Z coordinate of the design camber, sir. The other question is, as the girder was anchored at one end during erection due to differential thermal loading and diagonal tensile stress, if any, was there any chances of cracking while erection of girder? So during our presentation, we showed we had connected both the anchor span and cantilever span with the arrangement of extension plate with link pin, and at the top chord, and at the bottom we had put the buffer slab, which is, though it was not shown in the picture, it is a spherical type. I mean, it has some radius. So both connections were free connections, so there was no secondary stresses passing through the girder. And other stresses we had already considered in the design part, like axial stresses and bending stresses. The next question is, sir, as per the statement, the camber variation was nearly 22% above 10 operation. Is there any major camber loss in mid-span? If occurred, how it is rectified? So it is from sir, additional member civil RVNL, Sri Sunil Sekhar. Sir, the earlier question was from Subham Sen Gupta, Deputy Manager RVNL. Okay. This, sir, 22% camber was on positive side, it was not negative side, so it was not such issue, sir. Thank you.
Sir, there is one question from Mr. M. Gupta, sir, ex-ME, regarding whether this can be used for measurement of loss of camber, open web girders, PSC girders. So my answer is yes, it can be measured. It's called camber. Loss of camber is basically difference of two readings of a different time period. So once you measure the camber, I had shown in my presentation that camber is very well possible to be measured. So if you compare it is beyond a certain limit, prescribed limit, then it is a loss of camber. It can be measured. It can be PSC girder, it can be open web girder. Thank you, sir. Sir, here we claim accuracy to be plus minus 5 mm. Maybe, sir, basically we are focusing on the open web girder. Where there is a more accuracy involved, maybe we can use high precision equipment, because PSC girder are mostly not in those areas where it is very much inaccessible. No, so they are very much accessible, so we can measure that.
If somebody is from the RDSO or board, if we can lay down a thing, because when the girder is erected initially, if we start measuring from that point of time, and then we record every year at the time of AN inspection, then there will be a meaningful purpose. Because today what we are doing, we are comparing with the theoretical camber.
Yes.
And there may be a situation that when the girder is initially launched, there may be some variation. The correct thing perhaps for the maintenance engineer would be, when we make the girder, we commission it, we measure it. And then we keep on measuring, maybe for the dead load, maybe for the live load. And if that kind of thing come as a part of the bridge manual, then it will be institutionalized. Otherwise, it will be the person who will take initiative will do.
Sir, basically, hello?
So what you said is very much right. Actually, if we talk of a term called BIM, Building Information Modeling, 4D BIM has already been tried. POC is being done in Railway Board. One presentation was made. And there is a direction also. The idea is initially when a designing is completed, a digital model is prepared. As the construction happens, whether it is a bridge, whether it is a building or any other structure, in successive stages of construction, the model is successively created. So when we complete as-built 3D model is already there in place. So when it is handed over, it's a digital design model, digital constructed model.
Avasthi, the advantage of the railway is most of our bridges are standard span, 100 feet, 150 feet. So the point is if we make 4 or 5 models for the standard span, I'm not on the non-standard models, and then if we can give to the divisions, and they can upload, and then once in a year or maybe once in 3 years, once in 5 years, whenever we talk about the conditional monitoring, and at every node if we measure and we compare with this model, then perhaps, and if we, just like TMS, in the bridge inspection also abolish with the bridge inspection register and introduce everything online.
So we are trying to go a step ahead. For example, the CE construction presented a paper in which there was a camber variation from 5% to 22%. What I am saying is, as a design model, RDSO, if it's a standard model, we are already working on 3D model on that, and we are going to supply that. But in addition, when the construction is done, as a constructed 3D model is created, that's a part of BIM.
That's okay.
And when subsequent inspection is done using, let's say, this technology, that is compared with the as-constructed BIM model.
You have to do as constructed.
That is what you said. So work is already on in that direction.
Thank you. Thank you, sir.
Good morning to all of you. All the authors have presented very good papers, and we got very good response from the audience. While going through the papers, I recalled that in earlier days, they used to say that in 10 to 15 years, technology changes, generation changes. And now, with this speed, the way technology is changing, we feel that in probably every 5 years, there is a new generation, new thought process. Incidentally, I retired more than 6 years back, so you can say that I'm of the previous generation. But yes, whatever I could observe in these papers, I will like to summarize. Good development is taking place in track technology. The thick web switches, weldable seamless crossing, wider sleepers, heavier sleepers. And I'm also very happy to learn that with the use of wider sleepers, there is a thinking of reducing the de-stressing temperature, which will reduce the probably rail weld failures. One area which remains probably not properly attended is the welding of rails. Still, we have got large number of defective welds in the track. And in case if some outsider goes and sees the number of joggle fish plates, which are also causing problem in maintenance of the track, is really alarming. So I think this area needs attention of the civil engineers. Regarding this use of anti-creep devices, they mentioned while laying the CWR through yards. In the probation time, we were told that with the use of concrete sleepers, there is no question of creep. Creep was with the earlier type of sleepers like CST9 and ST sleepers, wooden sleepers. So while of course we should provide these anti-creep devices, but we should also look at the fittings, why the toe load is not adequate, why creep is taking place in concrete sleepers. This is very important. For laying the LWR on bridges, I think very good paper was presented. Also indicating the provision of shock transmission units at the ends. In the RDSO, I think there was some work also was done to transfer more longitudinal forces to approaches by increasing the length of guardrail and by using the heavier section of guardrail. So that can be also probably thought of, whether that will be useful. One paper about this regirdering of few spans of Vadibandha Bridge. This recalled that as a professional, we attended the first block in the railway for change of the deck plates of that bridge, Sandhurst Bridge, in which the stool also was provided between the footing and columns to make up the rail level. I have personally seen those areas for many years. It's a very complicated place, and I think the Central Railway has done a very good job in replacing those girders. And the paper also was presented well, indicating all the difficulties which they experienced during the regirdering. Only I would like to say that this probably the stainless steel has been permitted for the FOB and ROB. And probably in due course of time, stainless steel structures will also come for the dynamic loading, and which will reduce the problem of corrosion, which is presently, especially in the coastal area, number of bridges need regirdering on account of the corrosion. One other paper was about this provision of long span open of girders across Farakka Canal for doubling. In our times, the maximum span was about 122 meter. That the first time I think the Jowari Bridge was constructed near Goa. And in this only my observation is that as we go for the longer span, probably we should also adopt the modern technology and tools for fabrication of the girders, which will reduce the wastage of steel and also probably improve the fittings. The point which Mr. Gupta mentioned about this camber, theoretical camber and practical camber which we achieve, there will be, I think, lesser gap. And this practical camber we do measure, and we submit the papers to CRS before commissioning of the bridges. So that camber should be mentioned in the bridge register, so it becomes a reference point, as Mr. Gupta was mentioning. So in future, you can compare how much was the camber at time of commissioning and subsequently what was the camber. Now how much is the loss. One very good paper was about this LIDAR survey, and so it is really heartening to see how minor details can be obtained by this LIDAR survey, which will be helpful for survey and for planning the remedial measures. Only my advice is that please do not dilute our inspection schedule, because there is no substitute of physical inspection of the bridges. One more item I would like to comment is about this EPC contracts. Presently, a lot of EPC contracts are being awarded, and in which contractor has got choice to choose the span configuration and choose the type of girders which he would like to adopt. The only problem is that in case there is a need for replacement of isolated girder, then there should be a system with the railway that those girders can be replaced. When we are using the standard spans, this entire SOP was there for each span. But with the non-standard spans, I think there will be a problem. Similarly, in the track where the different type of fittings are being used, like I was told in dedicated freight corridor, they have, in each package there are different type of turnouts. Then adoption of those fittings, understanding of those fittings, and the procurement of those fittings will be a big issue during the maintenance. with these words, I also thank the organization for giving me opportunity to chair this session. Thank you very much.
Thank you so much, respected chairman and co-chairman, for doing the honors and chairing this session. Now, we request our chief guest for today to present the mementos to chairman and co-chairman. Can we please request Shri B.K. Gupta sir, AMCE Railway Board, to join us on the stage and kindly do the honors. We also request all the authors to please be around. Now we request Shri B.K. Gupta sir to kindly present the mementos to all the authors. Shri Parmeshwar Funkwal, Shri Harsh Kumar, Shri Chirag Mittal, Shri Abuzar Ghaffari. And we request all the authors who have presented together to stay back for a group picture. And next we would like to invite the authors of the second paper, Shri Satya Prakash and Shri S.K. Agarwal. Next, we would like to invite the authors of the third paper, Shri Nishit Kumar Mal and Shri Vivek Kumar. Next, we would like to invite the authors of the fourth paper, Shri Anil Kumar, Shri Hemant Kumar and Shri Ranjit Kumar. Next, we would like to invite the authors of the fifth paper, Shri Achal Jain, Shri Anisur Rahman, Shri Dinesh Kumar Sharma. Thank you and congratulations. Thank you so much, B.K. Gupta sir, for doing the honors. And with this, we take a 15-minute tea and bio break. We request everybody to join us back in the same hall at sharp 11:45. Ladies, check. All right, everybody. Can we have your attention out here, please? We request everyone to kindly take your seats. And I hope my voice is audible all the way in the back. We are going to start with the technical session 4. So without any further ado, I would like to welcome all of you to technical session 4. We would like to invite our respected chairman and co-chairman to chair this session. Can we please request Shri S.K. Gupta, CBE Central Railway, to kindly escort our respected chairman, Shri Shiv Kumar, former General Manager C, NF Railway, to the dais. Along with that, we also request Shri Suresh Pakhre, CEC Central Railway, to kindly escort our respected co-chairman, Shri Ashok Kumar, former Director General, IRISEN. Check. 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 And we request the co-chairman and the chairman to kindly present the opening remarks.
Hello. Hello. So there are 5 papers. Hello. Yes, sir. Good morning to all of you. Still it is good morning. We have not moved from good morning to good afternoon so far. So in this session we are going to have 5 papers. Hello. And the time allotted is?
10 minutes each.
10 minutes each. So hello. So all the paper presenters are requested to follow the timings. Nevertheless, it is possible to summarize the paper in 10 minutes time. Just give the concept. Now before I call the first paper writer, the chairman and co-chairman happens to be ex-DG recent, both of us. I have great inspiration from Shiv Kumar ji in whatever capacity he has, let it be DRM or the advisor vigilance, general manager, director, recent. So I feel privileged and proud to assist him in the capacity of co-chairman. So let us start the paper.
Check. With this, let's commence the technical session 4. Before we begin and before we start inviting the authors and presenting the papers, we request everybody, if you have any question for any dedicated or specific author, we request you to kindly raise your hands. Our volunteers are out there with pen and notepad, and you can mention your question and send it to us, and we will pass it on to the authors. And that we will take during the Q&A session after the 5th paper is presented. Now, without any further ado, the first paper is Implementation of Projects on EPC Model in IPRCL, Unique Features of Contract for NMHC Project Phase 1A. And the authors are Shri A.K. Gupta, MD, IPRCL, Shri A.P. Malik, Director, Works, IPRCL, Shri Mohammad Mehran Khokar, Deputy Manager, Civil, IPRCL. And we also request all the authors to please stay next to the stage after your presentations, because we will be handing out the questions to you for you to prepare. Authors of the first paper, over to you.
Good morning, Honorable Chairs and co-chair and my dear friends in the audience. At IPRCL, we are implementing several EPC projects and hybrid design and build EPC contracts, and we have had large experience on these projects on which this paper is made, and I will briefly go to the outline that what the paper is made of. And of course, we have got a lot of experience on this, which if you will ask questions, we will further clarify. So before going into the EPC, just I am trying to outline the frame of the contract. So as you are mostly in railways, we are doing item rate contract and everybody is familiar. But as you move towards the right and you allocate more and more risk and responsibility to contractors, this type of framework will come. Next will come build to design contract, then design and build contract, which is also called EPC, and then design, build and finance. And of course, the last one is the pure PPP project, design, build, finance and maintain contract. All these contracts, which contract to select for what work depends upon your type of project and your requirement, what you want to achieve. And some of the benefits of the higher forms are mentioned here. For a successful EPC contract, which is the main focus of this paper, you have these features on which you must be knowing, being aware and outlining and laying down the requirements in the contract. Design and construction requirements, unambiguous tender drawings. See, railway and highway projects are simple, single, unidirectional projects, so we are not much bothered about the tender drawings. But for complex projects like station development, modernization, that too bigger station project, you must have tender drawings, because no matter how detailed the criteria are laid down, without tender drawings, you cannot specifically mean what you want to say in the criteria. So proper milestones, judicious laying down of intermediate key dates, not only 1 or 2 completion date is not enough. And that too should be based on the physical features of the contract, intermediate, not on the financial completion or expenditure, which is presently the model followed by MORTH. These are the projects which we are implementing, and many we have completed. We are doing ROVs, 4 ROVs in Andhra Pradesh, and which is on the MORTH EPC model. We have also done on the same MORTH EPC model 1 ROV for Deen Dayal Port, which has already been completed in record time, without any cost escalation, without any significant time escalation. In 24 months' time, we have completed this 284 crore contract. Then we are doing very big and complex project, NMHC, on which the last one, on which this particular specific paper is concerned. We are also doing a tourist cum cargo inland water transport terminal at Bogibeel, which is being done on EPC contract, and it is being supervised at present by us. So, in addition to the EPC, we are also doing some hybrid model, which is neither item rate, nor build design, nor pure EPC. So, fishing harbor modernization projects at Chennai, Paradip and Visakhapatnam, and also we are doing some internal infrastructure project funded by government of Gujarat. They gave us fund and said, you implement whatever important internal infra you want to do. So these were done on the hybrid model between transition of 2 models. So these details of NMHC, my colleague Muhammad Mehran Khokhar will explain you, then I will further continue.
These are the details of NMHC Phase 1A project which IPRCL is implementing. Sorry. This is the details of NMHC Phase 1A contract which IPRCL is currently implementing, in which the principal project consultant is Messrs. Architect Hafiz Contractor, which is the master plan consultant as well as supervision. It is also providing supervision to the site. It is the renowned architect who is awarded Padma Bhushan, 3rd highest civilian award, for his contribution towards architecture. The original contract was for 522 crore. Which includes 25 lakh fees for solar PV management, which EPC contractor will be doing on behalf of IPRCL. And rupees 1 is kept for provisional sum. Provisional sum will be explained in the further slides. I will just give a short brief what is provisional sum. Provisional sum is, initial value of provisional sum is kept 107 crore in the contract. And as of now, we have awarded 165 crores of provisional sum in the present contract, and further envisaged total provisional sum is 450 crores. I'll briefly explain the master plan of the project. This is a uniquely one of its type complex project which have a huge museum including 14 galleries. The 14 galleries are included in the museum with its center. It is at Lothal town. Lothal town is the heart of the museum, which is representing the dogs, which is the oldest dog of India. Then that is the elevated central Bagicha, which is a vehicular arrival complex housing parking in it. Then it is a Lothal city. Lothal city, it is surrounded by States Pavilion. Then the eco resorts. These two are hotels which are based on maritime maritime museum. And then these 4 are the theme parks of the project. Then I am handing over to MD sir for further explaining the features of contract.
So these are the special features which I will detail in the subsequent para. So it's basically typically in EPC contract, design is done and execution both by EPC contractor, but in build to design, as you say, design is done by authority, EPC by other. Then in NMHC EPC contract is a unique, in which authority has done part design and the rest of design is done by EPC contractor. So in a EPC contract, you have to divide the cost of the entire complex project into certain cost centers. These are also done on scientific basis based on how you want to manage and control the project. So as you see, these are specific disciplines are separately categorized as per the estimate. Further, the cost centers are divided in this project in 37 sub-cost centers, as you see. And in these, most important thing I want to highlight is for preliminary and general requirements. We have allocated 7.04%, which is normally not done in MORTH or railway contracts. They only allocate for permanent works, neither for design, nor for establishment, nor for safety, nor for quality, which we have done here. Further, cost centers are divided into 223 milestones, which at present, earlier it was 143, which have further been subdivided by us in order to ease the cash flow. And these milestones are based on the actual S-curve plotted at the time of invitation of finalization of tender, based on the actual cost estimate. If this is not done correctly, you will force the contractor to invest money from their side, means negative cash flow, and it will hurdle the contracts. There should be intermediate key dates, which should be again done scientifically based on physical parameters, so that intermediately you force the contractor to expedite or accelerate based on if you have imposed any key date missed, LD will come into picture, and if subsequent key date is achieved, LD will get refunded. And there are always some uncertain, undefined items of work in which NMHC case, it was very huge amount of museum and galleries which were not designed in advance. For that, there is a provision of cost plus contract on 10% management fee for the contractor, on which all the tenders were invited and approved with the approval of the client, and then accordingly it was awarded and implemented at the site. Interfacing, if there are multiple contractors, provisional some contractors and some government of Gujarat contractors, some our existing infra contractors, so you must provide the interface mechanism, what is the role of each contractor and who will be the overall in charge of interfacing. Then there are other special features, like we provided for interest-free mobilization advance, but the recovery was in fixed number of installment, not linked with the progress of work. And we also allowed in the tender splitting of milestone on the request of contractor in order to facilitate the payment. Then the variation management, no matter how much you are outlining initially the scope of work, you will end up having some variations at site. So must specify a detailed process how it is done in the contract, post-award of contract. Other contract actions taken during the project execution was the relaxation in LD. So initially in KD1 itself, 10% LD was imposed. So 50-60 crore rupees blocked of the contractor. So it blocked their cash flow. So they requested, so we allowed 10% pro rata.
Kindly hurry up. Your time is already over.
10% pro rata recovery. These are the site pictures, actual. This is the conclusion. Based on the basic principles of contract requirement of a specific project, contract features can be selected. It is not cast in stone. So for complex project, you have to find what feature of which contract model, even hybrid model of two contracts can also be adopted. The necessary cost payment, site establishment, safety, quality, audit and design. There has to be some payment. Otherwise, suppose some bad quality work is being done. How will you ensure if you don't have control on the payment? So payments, certain milestones should be there, which is the monthly audit, safety audit and quality audit. Those should be there. And no matter how detailed one defines the scope, already explained. Provisional sum is a very important part of EPC contract for complex projects. In architectural finishes, utilities, diversion, furniture, artwork, landscape, these are subjective things you cannot lay down initially in the contract. Thank you.
So you can occupy your seat. We'll call you separately.
Yeah, next paper is adoption of heavy capacity hydraulic friction buffer stops in Eastern DFC. Shri Pankaj Gupta and Shri Veer Narayan. I'm doing your job.
Check. All right, thank you so much, the authors. As we move on to the next title of paper, that is of the adoption of heavy capacity hydraulic friction buffer stops in Eastern Dedicated Freight Corridor railway lines. And for this, I would like to call upon our authors, Shri Pankaj Gupta, CPM DFCCIL Ambala, and Shri Veer Narayan, Vice President and Railway Head, Tata Projects Limited.
Good afternoon. Respected Chairman, Co-Chairman, my seniors and juniors. I am Veer Narayan and my colleague, Mr. Pankaj Gupta. We are here to present the paper on that issue or topic which is not much discussed, but which is very important and which is giving very much importance in the coming train operations. Next. Okay. We will cover. I and my co-speaker will cover the subject, and I will cover the red slides, and he will cover the blue slides. Main thing is that we are covering the issue of buffer stops. Buffer stop are the stoppages devices which stops the train mass, uncontrolled train mass, or you can say overshooting train masses safely in the yard. These now we are discussing only end stops or overrun lines or sand humps. Now we are going further to the friction buffer stops, hydraulic buffer stops which are used in the metros. Now in this issue we will discuss the friction buffer stops because these are the heavy capacity friction buffer stocks which are being used in the DFCC. In frictional buffer stocks, the buffer stop uses the frictional energy to dissipate the energy of the uncontrolled train mass. Now, till now, there was less emphasis on these frictional buffer stops, but with the increase in the speed and increase in the load. Now we are talking of 6,500 or 12,500 train load and speed of 100 kmph. And also we are talking of the speed of 50 kmph in the loop. Now there are more chances of increase of the overshooting of the train masses in the yard. So we have to design our friction, our buffer stops in such a way that our train masses, they are controlled, their energy is dissipated safely. Because consequences of the inadequacy of buffer stock can be anything. Uncontrolled train mass, they can be derailed, there can be severe impact, and it can result in the damage to the rake as well as load, blockade of yard, and in some cases there has been the serious accidents. In South Central Railway, I remember that there was one accident where the train overshoot the end stops and it came to the train, road, there was flyover and it rammed into one bus. There was casualty of 12 or 13 persons. So it can be anything. Before going further, let us talk about the various types of the end stops. These are the first is the sliding type buffer stops, which we will discuss. The basic principle of these sliding type buffer stop is that they dissipate the energy of the train mass by means of the friction energy, which they dissipate by movement of the frictional forces. Then hydraulic sliding type. In this, the impact energy is converted into the hydraulic energy and dissipated. And then there are fixed hydraulic type buffer stop, which dissipate the energy of the train mass by means of the impact energy. But these provide the damage to the rake and can be suitable only for the low speed. In dedicated freight corridor, these have been designed. Till now we had the frictional buffer stock for 310 and 10 kmph speed. But we are dealing with the speed load of the 6,500, 10 kmph and speed of 50 kmph in the loop. So there is the need to provide the buffer stocks for the higher capacity. And unfortunately, in all over the world, such higher capacity, for example, in Eastern DFCC, the specially required that we have to design the frictional buffer stock for 6,500 load and 10 kmph. In all over the world, it has not been designed. There is one instance of the same in Australia only, which also is not tested. So we have to design these buffer stops by ourselves. And one company, Olio, they designed and we tested it in the Eastern DFCC and it was tested successfully. So the rationale for providing these buffer stocks in dedicated freight corridor is that we are dealing with the higher load, we are dealing with the higher speed, and speed of the loop is 50 kmph. So as the speed of the loop increases, the chances of overshooting of the train load, that increases. And that has to be somehow dissipated through the friction safely, so that our yard, our safety is ensured. So lately we have done the prototype testing of such one buffer stock in the Ambala division at 6,510 kmph, which we will show in the video later. Before going further, I will discuss just about the brief philosophy that how it works. Basically, any uncontrolled train mass, it has mass as well as one velocity, which needs to be dissipated. So energy which requires to be dissipated is half mv square. That is the kinetic energy which is to be dissipated safely through the buffer stops. Now, this energy is dissipated through the frictional forces. If you see the diagram, there are the frictional shoes below the frame as well as behind the frame. So when the mass strikes the frame, the frame transfers this load to the frictional frames, and frictional frames, they move with the certain friction. Usually it is 50 kilonewton. So when this force, half mv square energy is there, and it moves, slides. So this energy is dissipated by the frictional forces of the movement of the frictional shoes. And the energy consumed by the frictional force is equal to the frictional force multiplied by the displacement. So if there is more energy in the train mass, it will move slightly more. So the design is very simple. If we are designing for the higher load and higher speed, the displacement or the length of the sliding will increase. Now, one aspect, if you see that these frictional shoes are not combined together. They are placed at certain distance, because the main criteria or main principle which we keep in mind is that we have to slide this force frame, because if we have too much of the frictional forces at once, then it may result in the type of the impact. But our choice of the dissipation is through the frictional forces. So we provide the frictional force of the low magnitude in the earlier stages. When it slides, then it slides and combines the other frictional forces with it, and frictional force increases with the time, with the distance. So when it increases the distance and the energy is not dissipated, then it will go to the higher displacement. So that is the philosophy. Half mv square multiplied by the factor of safety is equal to the energy dissipated through the friction, that is summation of the frictional force multiplied by the displacement. Now I will ask Pankaj Gupta to give the detailed design of this.
Thank you, sir. I will go through the basic components which have been used in this friction buffers. You can see the anti-lifting device also with circular marks. Then friction shoes are also listed here. And then the friction frame has been used. This is the buffer stop, all the components of the buffer stop. So if we use the frame, then it gives the stability to the, when we push, then it gives proper stability to the track. Otherwise, track will be distorted. This is the schematic diagram of the friction buffer which we have used here. You can see the friction buffers are placed at a smaller distance, and as these friction buffers are placed at a somewhat distance with each other, because as the train pushes these buffers, the energy should dissipate slowly and steadily, not at once, so that there is no chances of any derailment and energy is dissipated in a steady manner. And I'll just go through. These are the detailed calculations, design calculations. You can see that half mv square is the energy which is to be dissipated, and each of the friction buffer consumes 50 kilonewton of energy. As this is derived based on the experiments, and later we have proved it based upon the live experiment which we have done in the field. This is again the detailed calculations. I will not go through into detail. And ultimately, when we push, the last pushing is done simultaneously with all the friction buffers, friction shoes and the buffer in one go, and it travels about 22 meters. So the total length of this friction buffer installation length is 36 meters, which we have summarized based upon the design calculations, and this we have proved in the field also. So this is the actual site installation photographs.
Kindly sum it up, your time is already over.
Then I will just go through the 1-minute video that will give you the insight how we have tested. We can see that this type of testing is not possible on the Indian scenario, but with the lot of interface and the support from the Indian Railways, we have got it experimentally done in the field, and the clip which is about 1 minute long will show you how these friction buffers were tested in the field. The load was prepared all the load was having the ballast load, and excess load was made up with the help of the loose rails attached loaded on a BFR and attached with the ballast train. So this is the trail load, which is initially moved at a speed of 15 kmph, and slowly it is approaching towards the friction buffer which we have installed, and you can see that it has ramped and it has come to a stop. Just I will go through the total sliding mass was about 6,624 metric ton. Speed was 10.5 kmph at the time of hitting, and the sliding distance was about 19 meters, and no damage has occurred. And then I will just go through the advantages. This is the last slide probably. The least chances of derailment, high reliability, practically no damage to the rolling stock, no damage to the friction buffer, cheaper in terms of life cycle cost, and less maintenance cost. The way forward can be developed and designed for higher load and impacting speeds. Resetting mechanisms to be part of maintenance for quick reinstallation can be developed indigenously 100% by IR, incorporation of suitable damping mechanism. Then with the advent of railways and the higher speed loads and higher axle loads, this is the way forward, because friction, conventional type of dead stops, sand humps require a lot of maintenance, and they are not economical in terms of life cycle cost and not safer. So this is the first breakthrough which we have adopted on DFCCIL, and we are likely to install on all our lines on the DFCCIL. Thank you.
Check. Thank you so much, respected authors. All right, let's move on to the next paper. And the title of the paper is Rising Speed in Mixed Traffic Region for Semi-High Speed Trains. And for this, I would like to call upon our authors, Shri Satyaprakash, ADG, IRIS in Pune, Dr. Sabyasachi Roy, Senior Instructor, IRIS in Pune, and Shri Bhoj Rathod, Senior Instructor, IRIS in Pune.
Respected Chairman, sir, Co-Chairman, sir, Chief Guest, and all my friends and seniors. So this topic, basically, this in the last PC seminars, we were. It was suggested that we associate with the NW Railway for doing calculation and all for upgradation of speed from 110 to 130 on Jaipur division of NWR. So we got the data from PC NWR, sir. I am thankful to him for associating us in this project. So this calculation, analysis and calculations we did for upgrading the curves for 130, 160 and 200 kilometers. So our Indian Railway scenarios, we have expressways are being constructed at a faster pace, which has drastically reduced the travel time between cities. And to remain in business, Indian Railway will have to go for high speed and semi-high speed trains. From my own experience, I can tell you that I worked in Malaysia in 2006 to 8, and we used to travel from Ipoh to Kuala Lumpur in 2 hours, flat 2 hours, 200 kilometers, flat 2 hours by road. And trains there were running empty, hardly any passengers in the train. Then they have to upgrade it to 160 kmph on meter gauge. So there was a Kuala Lumpur, there was a project up to Ipoh. Then Sramban Gamas double tracking project was there, for which Ircon did for design speed of 160 kmph on meter gauge. So if we don't upgrade our speed, we will throw ourselves out of business. So on this Rewari-Ajmer section, Shatabdi Rajdhani are running at 110 kmph. Vande Bharat has been introduced as 110 kmph. We need to, there is a demand, in fact there is a requirement to upgrade the speed to 160 kmph for running Vande Bharat in a viable mode. So we did calculations. This is the section of Rewari is in the top. Rewari is in the top and Ajmer is the on the left side. So total length of the section is 353 kilometers. It has got 255. It has got 255 curves, and Madar Jaipur division is up to Madar, that is 6 kilometers short of Ajmer. So that we did, and this was gauge converted section for meter gauge. So this is the calculation, the requirement of degree of curve for various speeds. For 130 100 kmph we require 1.65 degree curve. For 130 with 150 cant efficiency we require 2.09. For 160 100 cant efficiency we require 0.99. For 160 150 cant efficiency we require 1.129, and we require for 200 kilometers with 150 cant efficiency 0.77. So this is the pictogram which tells us that what degree required for a particular speed. Then speed of goods train has got important bearing because it limits our capacity to provide the cant on the track. So that is why we have calculated this. For different goods speed, the requirement of curvature or the degree of curve is 0.77 to 0.93 depending upon the goods speed. Then we analyze the section. It has got different curves up to 0.77 degrees. We have got 51 curves and total curve length curves are 30. So this is the data. I am not going in detail. So basically, this chart shows that 30% of the curves are fit for 200 kmph. Another 30% of the curves are fit for 160 kmph. No work is required. We require to do work on 4% of curves for 130 to 160. For 130 we require 36. So from 130 to 160 we required 4% increase. So this is the curve length. Curve length is about, total curve length is about 11%, out of which 6% is up to 1 point. For 130 kmph speed, we need to work on 6% of the curves. And for 160 kmph, another 0.43. So 6.43, incremental marginal increase. So idea is that why to go for 130, why not go for 160 and one go. Then this is the, just to show that if we have to do in realignment, that curve is shifted inside and there is an extension of a transition towards the straight. And this is the pictogram that tells us that how much, so we have samples of curves, different curve lengths, say 1.5, 1.5, 210, 110, 220, 450, then 2 degree. So different length of curve, how much slew is required for particular speed that we have said. We have mentioned here for 130, 160, and as we increase the speed, the amount of shift increases. So this is the different categories, say up to 5 meter shift, 5 to 10, 10 to 15, 15 to 30 and more than 30. So that we have worked out and summed it up. So total length of required for 130 kmph is 38 kilometer. For 160 it is 47 kilometer and for 200 it is 101 kilometer. So this is the pictogram showing all that details. I will not read this. I will come just to that. This is the basically final, that we need to realign the curved length to 38 kilometers for 130, 48 kilometers for 160, and for 200 we require 102 kilometers. If we take approximate cost of 5 crores per kilometer per track, the cost comes to 190 crores for 130 kmph. Then for 160 we need 240 crores, and for 200 kmph we need 510 crores. So this is what we have done in the pictograms. And this is the reduction of time what we can achieve. If we can go for 130 kmph, we can reduce the time by 15%. If we go 160, then time reduction will be 31%. If we go for 200, the time reduction can be 44%. So this is basically it's a substantial time saving if we increase the speed up to 200 kmph. So this is what we have done. Conclusions is that incremental cost of realignment for 160 kmph is 26% with respect to 130 kmph. Incremental cost of realignment for 200 km is 168% with respect to 130 kmph. Then time reduction, we have mentioned that it is 45 minutes for 130, 95 minutes for 160 and 137 minutes for 200. Incremental cost does not help. Incremental realignment does not help. Instead of going for 130, curve should be aligned for 160, if not for 200. I will recommend 200. So idea is that we should have one section where we can demonstrate that we can run 200. So Delhi Ajmer section I think is the best suited. It is a tourist circuit route and where we can do for 200 kmph. As our Honorable Minister says, fund is not a constraint. And we can, just like doubling we can do it, and cut and connection we can make and do 200 kmph. So this is all I wanted to say. Thank you very much.
So I think this is the first paper which is finished before time.
Thank you so much, respected authors. Let us move on for the fourth title of the paper, that is of Leading Paradigm Shift in Securing Track from Trespassing and Cattle Crossing by Innovative Fencing and Boundary Wall Designs. And for this, I would like to call upon our authors, Shri Sanjay Khare, CTE, Western Railway, Shri Vikas Garwal, Senior, DEN, Coordination, Ahmedabad, Western Railway, Shri Abhishek Mittal, DEN, Vadodara, Western Railway, and Shri Pankaj Chaudhary, SSE, Ratlam, Western Railway.
Namaskar, I am Sanjay Khare, CT Western Railway will present the paper. Respected seniors, chairman, co-chairman, and friends. Co-chairman and chairman are happen to the ex-director and the DG from the ERISEN. As being the ex-faculty from the ERISEN, I hope that I will get the slight leverage of the time, sir.
Surely.
Basically, this is not related to the core of the track, but this is an important peripheral activity which very much required for the ensure the safety. In the last paper, we have discussed about the increasing the speed on the track. So with the increase in the speed, this is required to ensure the safety along the track. This is a statement given by the Ministry of Railway in the Parliament. In the last 2 years, we have more than the 50,000 cases of the CRO. And all CRO are basically, they are affecting the punctuality, not only affecting the punctuality, they are the big source of the derailment. Recently, in the month of November, Indian Railway has the 2 derailment on the account of the CRO only. So this is required, and our track is passing through the villages and the towns, and this is the normal pictures for us. So this is a picture which has gone viral last year. After the introduction of the Vande Bharat in the Western Railway, there was the one CRO case, and there was a lot of discussion in the political circle also. So basically, this forced us for the paradigm shift. After this happened in the Western Railway, then there was thought in the Railway Board, we are executing the boundary wall along the track for increasing the speed to the 160 kmph. Then there was a lot of thought process has been gone in the Railway Board, and then something has been come out that we have to adopt the fencing which is to be based on the anti-cus barrier has been adopted in the NHAI. So we have gone through a lot of documents, that is IRC specifications 199, 99, and we have gone to the NHA sites to just examine that how it can be made viable for the Indian railway system. In the NHI, basically they are adopting only the 700 millimeter height of that anti-crust barrier, which may not be feasible for us. We require the higher height of that fencing for our system. Till the last year, right up to this 1 year back, in the last week of the November, it has been forced to us. Till that time, we are mostly adopting the masonry wall or the concrete wall based on the RDSO drawings approved by the RDSO. There is a lot of problem with the boundary wall. Boundary wall is definitely that is to be constructed at the boundary only. Otherwise, if we construct it with the track on the boundary, then we have to surrender the land beyond the railway boundary. Another thing is that is creating the physical barrier between the habitat area and the railway, and there is no visibility through the boundary walls. They're generally not been accepted by the habitants. So at the lot of places, it has been damaged by wherever it has been executed, it has been damaged by the habitants and the occupants. So basically, we required the fencing. Then the concept of the fencing has started there. Boundary wall will be there at the boundary, but for the safety of the track, we have to construct the fencing just near to the track. So in the Western Railway, basically we adopted the W-beam metal beam crest barrier based on the NHI drawing. And before that, the PSC precast boundary wall was also going on there. And recently, we have adopted one fixed rod fencing, which is cheaper than as compared to the other two that precast and the W-beam fencing. In the W-beam fencing, generally there are the two W-beams made of the metal sheets, and they have to be erected on the post. Post is to be erected at different intervals, regular intervals. This is the drawing which has been designed by the Western Railway and approved by the Railway Board. It has the 2.7 meter height post, 1.5 meter above the ground, and 1.2 meter is to be driven to the ground. And the post is to be erected at 2 meter intervals. It has the 2 millimeter thick W beam. In the NHI, mostly they are adopting the 3 millimeter thick W beam, and the post they are having the 5 millimeter. But when we interacted with the industries and we have gone onto the site, we have seen that generally they are supplying 2.36 mm the thick sheet, and the post is only in the range of the 4.2 by 4.5 millimeter. Just to safeguard the interest of our railway, we have adopted a 2 millimeter thick W beam, and the post of the 4 millimeter thick has been adopted. And then they are supplied basically the W beam is coming in the roll form, and they are having the length of about 4 meter. So because of the electrified sections, we have to provide the discontinuity in the metal fencing to avoid the induction. So there we are erecting the 16 meter long container in the stretch. Then there is the gap of the 150 mm. And the third and the seventh post has been concreted to ensure the reliability. But by our experience, I can say that the concreting is not required. Only the driving is sufficient for achieving the progress and ensuring the safety. And all these components has been galvanized to the 550 GSM. Whereas in the IS code, it requires only 460 mm. But to ensure the reliability and to ensure the longevity, we adopted the 550 mm GSM. So this is a contract. Basically, the challenge has been given to the Western Railway to complete the 400 kilometer work in the 5 months by the end of the May, and the process started in the month of December only. So we have divided the different sections in the 5-6 AN wise, and the contract has been awarded in the month's time. And 400 kilometer we are able to achieve it by the month before the May. Work is still going on to plug whatever the gap is there. These are the pictures from the site, how to close at the level crossings, how to close at the big site, and we have provided the access by providing the staggered fencing to provide the access for doing the inspection and other things. And where the undulated ground is there, terrain is there, we can adopt the step fencing is there. And for the executing the work on the first space, we have conducted the drone survey, and that helps us to take the decisions. On the Google Maps, all the cables available in the area has been marked on the Google Maps, and then we have worked out where the fencing is to be fixed. We don't want to disturb the existing movement of the villagers, so that acceptability will be there. So all these things has been worked out by conducting the various meetings at the different levels, at the divisional levels and at headquarter levels, and clear-cut guidelines has been issued to the divisions. This is a drone survey. Major problem is that the lot of cables are there in the railway area. So every time we are doing the works, there is a problem of cutting of the cables or punching of the cables. So all the drawings has been on whatever the drawing is available, that along the track, cables and everything has been marked, and the proposed location of the fencing has been marked, and all these drawings has been approved by all the branch officers and the DRMs also. So this is jointly done by the S&T and the engineering department, and we have the provisions of the cable route finder in the contract itself. And the contract, basically the cable route will be, that work will be done by the contractor, civil contractor. Agency of the civil, that S&T peoples will be there along with the contractor. And if there any the cable cutting is there or cable puncturing is there, that contractor will provide the help and the material will be provided by the S&T department. So that was the case of the metal fencing. This is another case. This is another case study of the PSC boundary wall, which we are executing before starting the metal fencing. We have the RDSO drawings for the precast RCC boundary wall. In the Western Railway, we adopted the PSC boundary wall. It resulted in the reduction in the weight of that columns and the other materials. We adopted that RCC foundation, that is also the precast. And for the different sections, we have given the contract for the boundary wall, and all around the 70 to 80 kilometer boundary wall has already been erected. These are some pictures of the site and the casting yard. These are RCC precast foundation. These are the columns. These are the pre-stressed panels. Recently, 2-3 months back, we started the slip form concreting for the RCC panels, which has been cut by the diamond cutters. This is the erection at the site, and this is the final finished boundary wall at the site. During the casting and the erection of the PSC boundary wall, there are some challenges. Basically, large area and land is required for set up the casting yard. Maybe around 6,000 to say 10,000 square meter area is required for that casting yard. An accessible approach during the monsoon, or if the water logging area is there, then the shifting of these panels is slightly, there is a challenge for us. And another thing is there, we required the fast-paced casting is required, then the coiring is to be expedited, for which we adopted the coirators which has been procured from the Germany. Steam coiring has been adopted, hot boiling water coiring has been adopted, and regularly we are doing the drone survey for controlling these objective points. Sir. And there's another new fencing which we are going to adopt it. This is the fixed knot fencing, which is the high tensile bar has been not at the each junctions, and they are the different not at each junctions. So cutting is not the cutting is basically that a lot of problem is there in the cutting the wires. So it is a theft prone. I will say to some extent. It requires double the energy to cut the wire, and it will not break. If we cut at the one location, it will not break automatically, and it can be repaired. And it has the aluminum and the zinc coating. It is better than but we are going for the galvanizing coating only. So this drawing has been approved by the Western Railway, and we are going to adopt it. These are the cost comparison of the three fencing which has been adopted in the Western Railway. WB generally it is coming to 4,000 per square meter per running meter. PSC boundary wall it is coming to the almost 6,000, and the fixed knot is maybe around to the 2,700. This is the CRO cases versus what is the progress of the fencing. So in the first, there is the nil case after the erection, after completion of the work. In the second also, after the completion of the work, there is the 0 CRO cases. But in the Baroda division, there are some few cases are still there that we have to plug all the block sections. It has been erected to the number of the blocks gaps are there which has to be plugged. So challenge is there. Yesterday, the gents had told that we have that lot of work has been done in the milestone work has been done in the Indian Railway, gauge conversion on the mass scale. Then there's the level crossing. I think that this is one of the things which is coming for the next 4 or 5 years. It is required to be done in the Indian Railway to ensure the safety in the higher speed route. So other than the three systems, there are a lot of systems in the market. So depending on the fine cell probability, it can be adopted in a different network. I hope that. And basically, if we consider that, considering the Indian Railway route of 60 to 7,000 kilometers, it requires a 30,000 to 40,000 crore work is required for the fencing. So a lot of evaluation is required in this area. Still, a lot of is to be done. Thank you very much.
Thank you so much, respected authors. Let us move ahead with the fifth title of the paper, and that is the introduction of the modern track inspection technology in Indian Railways Integrated Track Monitoring System, ITMS, new TRC. And for this, I would like to call upon our authors, Shri Rahul Singh, Director TMM RDSO, and Shri S.K. Banwal, Executive Director Track Monitoring RDSO.
Good morning to all. Respected Chairman Sir, Co-Chairman Sir, respected AMC Sir. Our paper is on the topic Introduction of Modern Track Inspection Technology in Indian Railways. We have developed this paper on our experience with Integrated Track Monitoring System, which is a new type of TRC, popularly known as ITMS. And we have developed this paper with under the guidance of our ED Sir, S.K. Banwal Sir. Sir, Integrated Track Monitoring System, ITMS, is a type of TRC which has 6 subsystems, and the first 3 systems were there in Indian Railways in some form or the other, which is the track parameter recording system. We have full rail profile and wear measurement system in this TRC. Earlier there was only half rail profile, and the benefit of full rail profile we will discuss in coming slides. And acceleration measurement system at coach floor level and axle box and bogie pivot. Now these 3 systems, which are highlighted in blue, are new subsystems introduced for the first time on Indian Railway network. Infringement of SOD envelope, condition monitoring of track components by video recording, and rear window video recording and all these are used for condition monitoring of track features. The first subsystem is for measurement of unevenness, alignment, gauge, twist, super elevation and curvature. Inertial principle is used with contactless laser sensor based sensors, and online reporting and alerts via SMS and email of UML peaks of gauge, twist and acceleration is provided from this TRC with location to PV officials through mobile network. Here it is an example of one of the SMS, like on 19th November 23 in Asansol division from kilometer 216 to 204. This is the summary of the UML peaks. We have to provide in SMS for 10 kilometers due to limitation of number of characters in a SMS and number of SMS that can be sent in a day. So this is minus 12.77 at chainage 213, 322 and 3. That means in kilometer 214 to 13 at this particular chainage, there is a UML peak of minus 12.77, and then there are total 3 number of peaks in that particular kilometer. Simultaneously an email is also sent, which is shown here, and here we can see the details of 3 individual peaks. So by this, the user can identify the location and attend the location. So moving ahead with the track parameter recording system, it is a non-contact laser inertial sensor-based system, and all the measurements are in conformity to the EN code EN13848. The system consists 1 IMU and 2 optical triangulation units. And all these are integrated on one frame which is installed on the bogie of the track recording car. The optical measurements are based on triangulation method, and which are implemented by combining a laser line emitter and high-speed camera. We have developed this format with help of Chris, and this is available on TMS. After the track recording cars run, this TRC parameter at a glance can be seen on TMS. This is the block for urgent maintenance limit. Whatever the urgent maintenance limits report are there, These are summarized here and with details can be accessed with these hyperlinks. Therefore, and similarly, need-based maintenance, peak-based and block-based are here. Need-based maintenance, SD-based is, this block is there. And for planned maintenance, this block is there. So by looking at this report, we can evaluate overall summary, and if we want to go through detail, we can easily go ahead. This track maintenance planning chart is also available on TMS. I have taken of one sectional PWI, in charge PWI. In these rows, we can see that what are the tamping due on given date based on NBML, based on PML, NBML latest run, PML latest run, what is the OMS peaks in this section. So with the help of TMS, TRC result can also be evaluated in graphical way, in more user-friendly way for planning by PWI level and higher level management. So this is the second system which uses the same hardware as the first system, and this is the full rail profile measurement system which measures complete rail profile at every 25 centimeters. And as we are measuring the complete rail profile, we can also detect the rail section 52 kg or 60 kg, and we can evaluate wear and other parameters. The only limitation of this system is that if there is an infringement like a polythene or a rag or a paper between the laser camera and the rail, then rail profile is not properly formed, and then there are some absurd values which we identify and we eliminate those data points. The next system is for measurement of acceleration. We are measuring acceleration at coach floor level in the TRC coach. This is an additional accelerometer that can be placed in the test vehicle, that is locomotive or adjoining coach, and also we are measuring acceleration at the axle box. Now this is one of the interesting system of the ITMS. This is the measurement in infringement of SOD and MMD. This has 24 sensors, 6 sensors on each side, left, right, top and bottom, and which measures, which is the LiDAR sensor, and measures the infringements. It measures the point cloud of the 360 degree, and then by imposing the SOD envelope, we can identify the infringements, and we can input any number of SOD envelopes. But it has a limitation that ballast, which we do not consider as an infringement in SOD or MMD, is also considered because it is captured and it is considered. And if there are thick vegetations, then also it is captured and measured. So this is an example. The TRC is going inside a tunnel, and all these red marks which are shown, these are the infringement in the SOD. Recently, the TRC has inspected by this system a tunnel in Southeastern Railway, and a feedback was received from Southeastern Railway that tunnel lining was damaged by an ODC consignment, which was in their notice. They were taking corrective actions, but it was also identified by this TRC. This is the next interesting one of the interesting components. The condition monitoring of track component, in which we have LED lights and 2 rows of LED lights, and then we have in between 4 cameras. These cameras cover the complete track section, and by that, after the track section is covered, artificial intelligence is applied and deficiencies in track components is identified. We can identify rail cracks, longitudinal and transverse, gauge corner defect, area defects, gap at joints, sleeper. In sleeper, we identify crack, misalignment, sleeper spacing, vertical level with respect to rail top. In fastening, missing clip, missing fish plate bolt, base plate cracks, ballast, excess of ballast, lack of ballast, level of ballast, vegetation check, med pumping. And limitation is that this is an artificial intelligence based system. It requires clean section. If over ballasting is there, then there may be some absurd reporting or incorrect reporting of sleepers falling. and if condition of fittings or track components is not good, then also the system gets confused. Here, this is the ideal ballast profile which is shown in pink, and the black is the ballast profile which is captured by the system. By superimposing at every sampling interval, we identify at every sampling interval what is the percentage less or percentage more of the ballast. And if there is a continuous excess or continuous lack of ballast, then we report it. That is up to us. We can change that setting. This is an example reported by the TRC of missing clip, missing bolt, area surface defect on rail. The sleeper spacing, if it is beyond 20 mm plus minus, it is reported, identified and reported. Sleeper spalling reported by the TRC. Misalignment of sleeper reported by the TRC. Joint gap, here it is reported by 8 mm, and we have initial setting that if it is more than 2 mm, it will be reported. SEJs are identified and the gaps is reported. Cracked sleeper, if the crack is of more than or equal to 2 mm and for a length of more than 20 mm, then it is reported. Now this is a sixth subsystem in which we record that rear window view of the TRC movement, and at every pre-known location, wherever the light level crossing, bridge approach, etc., this kind of report is generated. The only limitation of this is that we must know the chainage of that asset, and that must be fed into the root data tape. Now, this kind of video is recorded and that is stored, used for the report generation, and also given to the zonal railway people accompanying the TRC by writing it in our DVD. Several representations have been received from zonal railways that the gauge peaks which are identified by TRC are not available in field. For that, we have jointly checked the with field many times, and every time it is found that in the well-maintained tracks with having proper ballast cushion, good fittings and proper tamping, the gauge which are reported by TRC are found in field within a range of plus minus 2 mm, for which we have again prepared a detailed presentation and shared with zonal railways. And a new user interface is also developed at TMS for these new features, for which all the reports can be generated for infringements in schedule of dimension, rail profile defects, vertical wear, rail wear, lateral wear, sleeper defects, rail defects, fittings, vegetation, and etc. And on conclusion, I would like to say that as we are moving towards higher speeds, and inspection will be very difficult manually in higher speeds, so such kind of systems must be are the solution. And this ITMS is the beginning, and we have a long way to go. Thank you.
All right. Thank you so much, respected author.
There are large number of questions, I think around 35, 40. And since we are already running behind the schedule, so with permission of the chair, I will request all the authors to take 2 questions each, and balanced questions can be discussed by whoever asked during lunch time. So every author will request to take 2 questions each. So all the authors to kindly come to dais for answering 2 questions.
All right. As we begin with the Q&A round, I would like to call upon all our authors on the dais. Can we have Shri A.K. Gupta sir, Shri A.P. Malik sir, Shri Mohammad Mehran Khokar, Shri Pankaj Gupta sir, Shri Veer Narayan sir, Shri Satya Prakash sir, Dr. Sabyasachi Roy sir, Shri Bhoj Rathod sir, Shri Sanjay Ghare sir, Shri Vikas Gharwal sir, Shri Abhishek Mittal sir, Shri Pankaj Chaudhary sir, Shri Rahul Singh sir, and Shri S.K. Banwal sir.
Okay. One question which I have received from Mr. Ashok Kumar Gupta. We are talking high speed, 50 kmph on loop line and designing buffer stop for impact speed of 10 kmph only. Any reason for going for such low speed, 10 kmph? Actually, whatever system we design, we have to design considering the probability of the load coming and the probability of the speed coming. It may be possible that we may have the speed of 6,500 and the high speed, but probability of that will be very, very less, and the cost involved may be very, very high. So we have to balance the load and the probability with the design. Because when we increase the load and the design, the sliding distance will increase. For example, in this case, 6,500 and 10 kmph, the sliding distance was 34 meter. And if we increase the speed from 10 to 50, then it will increase to 130 or 140. And that may not be so much economical. So we have to take the probability of the occurrence of the event. Second is what is the uplift force calculated on the buffer stop and any provision taken to avoid the uplift. Actually, when the load strikes the frame, it strikes at a certain distance, at a certain height. So it gives the overturn. To overcome that overturn, we have designed the, if you have seen the drawing, that there is anchor block at the starting of the buffer stop, which prevents the buffer stop to uplift. Apart from it, there is frame, steel girder, which is provided below the sleepers so that this track is not uplifted. Any more?
In continuation to this, there are questions from Mr. Deepak Sablok, Executive Director, Econ. After hitting the friction buffer stop, will there be any damage to the bottom portion of the rail, sleeper or overall track structure? There will not be a damage noticed because it has been connected to the underframe, which is very sturdy. And will the friction buffer get displaced, and after every time it has to be put back? Yes, there will be very little chances of train getting overrun, and once in a blue moon type situation will occur, and after that it can easily be restored back to the same position without any damage. The last one I will take from Atul Khare, Executive ED, ID, MRC. When in the word buffer stop of 6,500 metric ton was not available and no design was available, how design validation was done? So we have to go for experiment. That is the reason why we have adopted a field experiment, and based upon the trials, initial trials in 2021 has been failed, which was done in Tundla region. So now with advanced design, these trials were done, and now these has been successful, and based upon the field trials, every design has to undergo a field trial, and based upon the successful field trial, adoption is done. That's why we have kept our topic also, adoption of friction buffers after trials. Thank you.
The question is from Sri VP Singh, PCNR, that Lothal is a historical site, and if we are working there, what are the provisions to deal with the new historical discoveries while working there? The answer is that we are not working at that historical site. Our work site is about 3 kilometers away from that site. The remaining questions deal with how do we deal with the variations in the contract, and whether imposition of the LD upfront will not incentivize the contractor. For the variation, we have a very tight, watertight laid out procedure in the contract, which was detailed in the presentation also and is available in the paper. And for payment of the variation, it is a new milestone. It's framed. And to improve the cash flow of the contractor after imposition of the LD in any key date, some concession may be given. That provision is there available in the contract.
This question is from Mr. Deepak Sablok, ex-director project IRCON. It is seen from the presentation that IPRCL has used hybrid model of execution of EPC. How did you address issues regarding design, payments, other than what has been presented. So actually, we had the experience in two of the contracts, one in the fishing harbor modernization, where in the short term we had to invite tender as the client said that it is to be inaugurated soon. So the milestone fixed was not proper. So the contractor is not getting proper payment and work is not progressing. So that issue we are now managing with the splitting and also changing the milestone. But as we cannot change the milestone of prepayment, so we are taking bank guarantee from the contractor. And another was in the internal infra of the NMHC, which was funded by Government of Gujarat. So there what happened, the design which was done by our Hafiz contractor team, that when the excavation started, it didn't match with the soil because soil was very, very fluid. So the design was required to be changed. So when the design changes, the item changes. So actually in these hybrid contracts, we have provided BOQ item-wise and quantity-wise and amount-wise. And it is mentioned that if there is any change in item, then the variation will be decided in the overall lump sum cost based on those BOQ item changes. So BOQ are not used for payment, but used for changing the scope. Another item is for standardization of design bridges is the feature of Indian Railways. This is the last one. Okay, thank you.
Sir, I have a question from Ekbote sir, retired AMC. Madar section of NWR is a converted section from MG, heavy, large number of sharp curves sharper than 2 degrees as a result of huge shift are required. While calculating the cost involved, it has been considered individual curves for land equation, bridges getting affected and lateral shift. Sir, it's certainly true that it has got lot of 2-degree curves and they have to be realigned for 0.77 degree curves. We have considered the individual length which has to be realigned and considering that as 50% of that is a new bank, including bridges. So 5 crores we have cost as an indicative. It's not, we have not gone to do detailed survey. And it will require land equation also, but those can be details report is prepared, then it can be actual cost can come, but this is just indicative. Another question is from Mr. Vivek Gupta. Present IRPWM provisions are limited to maximum speed of 160 kmph. For speed over 100 kmph, say 200, whether other parameters are lagging or maintenance as specified other than speed on the curves. Sir, we have done only study on the curve only. We have not gone into other details. That is too big a study to be conducted. And if we decide that we go for 200, we will get parameters for that also. If Malaysia where we have worked meter gauge 160 kmph, they can do it. Then we can certainly do 200 kmph on broad gauge. So that is all I can take. Others I will discuss separately.
Namaskar. Here are the 7 questions. I will just take the 2-3 questions. This is the first question from Mr. Neeraj Jain, CT. We have been witness to the pigeon trapped in the hall as and the analogy what measures are to be taken to ensure no cattle enter the fencing zones through the level crossing in the station area. So we will take that precaution is to be taken definitely at the level crossing at the stations to prevent the entrance of the cattle. Another thing that this is rightly pointed out, I've just missed in the presentation. Recently during the inspections by the MI in the Western Railway, he suggested that we have to provide the bucket gate system that which permit the movement outward only. If any cattle entrapped in the area, then it can be escaped through that. That modification is required, definitely, sir. And this is another question by Dr. Baipi Singh, AGM, retired AGM NCR. The fencing proposed and used by the railway are quite costly while not being permanent or effective. DRDO has developed some type of the natural or herbal fencing which repels the animals, may like to contact the DRDO. So definitely there is a scope for the evaluation I told earlier. It is not come to my knowledge. We have seen the 5-6 type of the fencings. One of the bamboo type of the fencing has been suggested for us, but it is costly as compared to what we have discussed in the all three has been discussed in the presentation, sir. So I don't know the cost right now. What is the cost of the herbal? Similarly, on this line, there is a bamboo crest barrier have been successfully tried by the NHAI. This design can also be adopted in the railway. Definitely it can be adopted, but it is costly as compared to the what has been presented in the presentation. It is costly as compared to the it is an advantage. Okay, sir. Oh.
It has got a bigger advantage that it will not be prone to theft, because all this material that we are talking about, theft is a very big issue which we will have to face in coming years.
So basically, we designed the bamboo-based fencing has been also designed by the Western Railway. It was costing around the 5,000 per running meter, sir. It may be environmentally friendly. It requires the different types of coating. Chemical coatings are there on the bamboo material, sir, and that it costly as compared to the metal fencing. Sir.
No, that is today's scenario that we are talking. I think afterward.
Sir.
It's a very big topic we can discuss during the lunch time. Because he has answered.
Thank you very much, sir.
Western has considered this option. Much time for you too.
Hello. Good afternoon to everybody. In this session, 5 papers have been presented, and you see there is no connection among these 5 papers. It is a wide variety. From EPC mode of tendering to the this fencing, from high speed on curves to TRC, and of course a new concept for the buffer design. So summarizing these 5 papers, and these papers are very, very interesting, and they're getting the response from the audience. The maximum questions have been received. More than 40 questions have been received in this session on these 5 papers. First is regarding the EPC mode of tendering. In railway parlance, there is some resistance which I have experienced during my tenure as DG Recent. During the interaction of various CEOs, somehow there is inbuilt reluctance among the officers to go for EPC mode of tendering. Board has given adequate guidelines. In fact, we have conducted a number of courses to train our officers and to clear their doubts also. And thereafter, there are certain clarifications given by Recent based on which board has issued the revised criteria also. But even then, there is a stiff resistance in zonal railways to go for EPC mode of tendering. And one of the very important reason is how to handle the variation. This is the one aspect in which we lack some sort of clarity, but nevertheless one unique method of handling the variation has been given in the paper. Probably we can think of getting some section issued by Railway Board regarding the variation to be handled in EPC mode of tendering. One of the very important aspect of EPC mode of tendering is the giving the stage payments. We call it the cost centers. The DFC, when they started doing the tender way back in 2007, 8 and 9, somehow the cost centers were not properly taken care of. They were highly skewed. For example, if the contractor is incurring initial cost centers starting from the bank, he was incurring a cost of around 100 rupees, he was getting merely 20 to 30 rupees. So there was a decision to go for variation in these cost centers. So I hope that there should be inbuilt mechanism in doing in getting the variation sanction during the execution of the contract. It will make us acceptance of EPC mode of tendering relatively higher at the field level, especially CO construction unit. And they have gone almost twice the sanction cost in this project, which they have presented in the paper, and without any much variation in the time frame. From 2 to merely 3 years they have gone, and they are going ahead with the projects. Now there is an inbuilt mechanism which they have done hybrid mode of tendering. A small quantity of BOQ has been given, and if there is some variation, the contractor can be paid regarding the accepted rates given in the items. I tell you one of the very interesting item regarding the comparison between the conventional mode of tendering and EPC mode of tendering. There is a famous bridge on Son River in EC Railway. One bridge was constructed on this Son Bridge by Indian Railway, that is ECR, and another bridge was constructed by DFC over the same span. Of course, the railway bridge was constructed foundation was 4 tracks, superstructure was 3 tracks, and this DFC bridge was simple for 2 tracks. Cost was not the issue; it was accepted by the contractor, and the simple TC was there. Indian Railways, the time was taken by more than 10 years, and finally they landed in a huge arbitration cost of nearly 150 crores. Whereas EPC mode of tendering, which DFC has followed, there was absolutely no variation. It was completed well within the time. All the conditions which are going to be there in the execution stage have to be properly spelt and taken care of at the time of framing the conditions. And there has to be variation, and the new unique idea has been given by the paper presenter regarding the handling of the variation. Another paper is regarding the buffer stops. Since our childhood, we are seeing the buffer stops at VT and Churchgate stations. There is no use of it. But as the famous saying, the rarest of the rare event can happen. And Balasore is the example. We never had in the past such type of accident can happen. So a new concept has been given by this team of DFC and this Veer Narayan from Tata's construction side regarding the design of the buffer. I mean, it is unheard so far. We are taking the buffer for granted because it has never been used. But nevertheless, a wonderful design has been done, including the field trial. Around 20-30 meter distance is not much. It can be further modified depending on the field trials and the type of buffer and the type of dissipation of energy which they are trying to absorb by friction. And this new concept has been given by this team of Veer Narayan and Pankaj Gupta. Third paper is very interesting. A study has been done to increase the speed, especially on curves. The data has been taken from the NWR. Very interesting because NWR, the section Rewari, Madar, Palanpur and Ajmer, it falls the earlier on MG regime, and more or less the same alignment was followed while doing the gauge conversion. Now they are going for the doubling, and of course with electrification. The important thing is in the mixed regime, it is extremely difficult to go for the higher speed unless we increase the speed of the goods train. There is already a sanctioned work which is going to raise the speed up to 160 kmph between New Delhi and Howrah and New Delhi and Bombay. And I still remember that the cost of New Delhi Howrah is nearly 6,000-7,000 crore of rupees. And after putting so much of investment, there is hardly any speed gain. At the Rajdhani, we conducted actual trial from New Delhi to Howrah, and the speed gain was merely, this time gain was merely 15 to 20 minutes. Why? Because we are not tackling the curve properly. So a new concept has been given generally on all these technical papers. We forget the cost component. But nevertheless, this gentleman, ADG Erison, has taken a tentative cost of 5 crore per kilometer regarding the realignment, which is very, very subjective. Because realignment, whenever the shift takes place, you may come across for construction of new bridge, shifting of the embankment also. So what we suggest, whenever we are going for higher speed, the curve has to be tackled properly. The curves can be decided into two categories. The curves for which realignment can be done without land acquisition can be tackled first, and the curve requiring the land acquisition can be tackled later. Of course, the construction of the bridge falling on route have to be taken care of. Very good paper has been presented by a team of irrigation officers. Thereafter, the concept of this fencing, three type of fencing concept has been given by Western Railway, and almost all of them have been tried. What we feel, board should not give any criteria of construction of this fencing. It should be left at the PC level. PC should be final authority depending upon the type of terrain around that track, bank height, etc. And of course the cost and the provision in the budget. He can take a call and decide the type of fencing accordingly. A good beginning has been made, and they have done a detailed study also regarding its effectiveness on Western Railway. Another paper has been very, very interesting regarding the type of TRC. It was beyond imagination. At least I have worked in the track machine directorate also, in RDSO. It was beyond anybody's imagination. A track machine will be able to pick up the details of the track. And the track components, which comprise of rail, sleeper, fastening and ballast. It can give you the rail profile, it can give you the sleeper spacing, it can give you the sleeper, how many sleepers are broken, it can give you the number of pendular missing, and it is unthinkable, unimaginable. So such type of wonderful machine has already been put into service and commissioned, and a very good paper has been presented by RDSO. So now I request my chairman, sir, to kindly summarize.
Very good afternoon. There are two timings when you fear during a seminar. One is post-lunch and one is before lunch. Because everybody is looking towards the sumptuous, delightful food which is awaiting outside. Later on, of course, after the food, some sleep factor. But nevertheless, whatever time has been allotted to us, we'll complete the job. So let me first thank my co-chairman for summing up all the papers in a very nice and concise way. Yesterday, while watching the cultural program and enjoying dinner, I just put in my request to him that you please focus on the paper part. I'll just close it by giving some final remarks. I think he has really helped me in fulfilling my request. In any seminar, I consider the success of a seminar is basically, firstly, by the delegates who come. And as I can see from here, because when sitting in the front row, you cannot look at the back. But now I can see very clearly all the chairs fully occupied. So I can see from all over Indian Railways, PV engineers have come. That's really fabulous, I call it. So that way, this seminar has been absolutely successful. And second part of success is due to the quality of the papers and by the presenters. And this particular session, I consider myself fortunate that organizers have given me opportunity to chair this session. Whereas, like my chairman was saying, all the 5 papers are in a different subject. But fortunately for me, all the 5 papers, when I was hearing, yesterday I was going through the book also, I found I can relate with them very closely. Because in my railway service for 38 years and later on in 10 years after superannuation, I worked almost with the contractor side, with PMC side, and RDSO also in the earlier career. I can relate with all the topics very closely, and I can appreciate the efforts which people are doing. So let me begin with first paper by IPRCL. I think it was a wonderful paper in a subject in which still people are not very clear. So, I would like to put in only two aspects. There are two basic requirements if you want EPC to succeed, which must be there. One is called risk factor, risk allocation, and second is about trust. By risk allocation, I mean to say that once you are giving a contract, you should not think that I have given now this contractor this job, now it is his baby to produce the result. We must see that have we done our homework before giving this contract. And as I told you from experience I am quoting, I was given this opportunity as a contractor to execute a work of track relaying. And in that contract it was a design build contract. Now in a track, design build means each component of the track has to be designed by the contractor. And for 70 kilometers contract, and now imagine a contractor has to design. Firstly, he should not have accepted this contract like in this way, but having got the contract, now it's his baby to deliver. So finally I was to do this job. So I found for each component, we have to get the design approved. And design means through RDSO. And RDSO, as you are aware, there is a mechanism, of course, whatever speed they have got, it's from their point of view, it's okay. But there are stages in which you are stuck up. Like I'm quoting rubber pad, 10 mm rubber pad was to be used. Now in that 10 mm, it was never used in the Indian Railways. So design is okay, even a contractor is available who can manufacture this. But MNC lab, they said, we will test them and then only give you whatever report. Now MNC, somehow the machine failed. Now they said, we cannot give this testing to an outside agency. So what we found out a way that we transported the machine from the contractor's premises to RDSO, Lucknow, got this thing tested and got it okayed, and then this machine was moved back. So these are small issues, I said. So my point is that if you are clear that this design is not possible by the contractor, better thing is that let the employer, when he is floating this type of contract, he can give his design. It will take some more time, of course, I agree. But then contractor is not like going through all the rigmarole. Even there was a turnout, because there was a presentation on turnout also in the morning through the welded track. So first time a turnout with higher speed potential is being tried and is all totally welded track. So no design is available. Again, this contractor he may be required to hardly 30 or 40 turnouts will be there in his territory. So 30 to 40 turnout, he has to produce a design. Unfortunately, again, I had to go through some Spanish agency. I got his whatever design, got it okayed, and got this manufactured. So I'm trying to say that this part of risk allocation, which IPS also has quoted, that you must first decide that who will do this design aspect. Second is the trust factor. Trust factor means there are three stakeholders. One is employer, one is contractor, and one is engineer. We call it PMC, whatever parlance. So between them, there is a role divided. There is a general condition of contract. It could be FIDIC, it could be your own. It lays down the responsibility on the three stakeholders. Now, it should not happen that the respective agencies are bypassing. Suppose there is already contract in position, PMC is in position. It is now between PMC and the contractor now to work out the details, whatever is there in the contract, and get it executed. But it is seen more often, contractor going to employer quite often and telling that this is not possible, that is not possible, do like this, do like this. So then ball is turned towards engineer to do whatever solution part of it. So I call it that you must give him some breathing space. Engineer has his own role. You have given under the FIDIC rule all the your powers, because that's what the beauty of this contract. That you have given the power to engineer PMC to execute this work. Now he should be at the liberty to execute it in the way it is defined. So having said this, now I'm moving to another aspect, because of course this whatever paper could not cover all aspects, not possible also. But one important requirement for such contracts to succeed is a selection of subcontractors. Unless we get good subcontractors, you cannot deliver this thing. Now, you are all aware, coming from various zonal railways, the availability of subcontractors. They have not hardly done few crores rupees work, and we are asking them to do 50 or 100 crore. So you have to develop them gradually and then see to it that they become the real backbone. Thirdly, important requirement is the cash flow. Any contractor, whatever it may be, Tata, it may be L&T, it may be Ircon, it may be any contractor, he cannot deliver it unless he has got money in his pocket. Because he can pour in his initial money, but later on he expects some money to come from the work only, that will be plowed back. So in that cash flow, I found a good suggestion by subdividing cost centers. If you preconceive that, how can we help? This is a good way. Like I remember in one contract, it was written, you will pay the bridge work by the linear meters. Now, as we are all aware, bridges, there are so many bridges, so many multiple spans are there. So all bridges cannot be completed in the uniform whatever way. So unless you will pay only per meter, and per meter never be done, because either the foundation, some pier will be in the foundation stage, some will be, columns will be at whatever stage. So this creates its own complication. So its better thing is to make very clearly what cost centers are there. Or you break milestone also, that was a good suggestion given. Now variation management, of course, my co-chairman has already talked. So we have to find out, of course, cost centers are there, cost, whatever we have given the mechanism for payment, and if you have not visualized properly, there will be variation. There are 100% chances. There is no way it cannot be there. But you have to find a solution, as he said, by giving a shadow BOQ, only for the purposes of looking into what are the quantities. Otherwise, he will quote the rate also from that. And lastly, the relaxation in LD. Because employer is watching only one thing, progress. Now, if he is watching progress, he is more concerned whether any milestone has been breached or going to be breached, then he will be more concerned. Now, what do you do if it has a breach? So, you have to impose a punishment by way of imposing liquidated damages. Now, they are too huge. So, what we can do? Either we allow it and work to stop. Is it the solution? No. So, better solution is you also agree to pay, to charge a liquidated damages in a proportionate way, as he says, proportionate to the billing amount. So these are the few challenges, because as yesterday we were told, more and more works are getting allocated to the APC mode. So we will have to get into the solution of these aspects. So I want to make a 3 suggestions in this particular paper. One is that you are not concentrating, because we have IRISAN, we have our institutes for training our subordinate staff also. But what about contractors, officials? There's hardly any mechanism. We recruit whatever I said, the big contractors, but big contractors, they don't come at that high level. So they also employ some from the field, whatever officials, engineers, and whatever. There's hardly any knowledge of the railway engineering to them. So I still recall, as a director, IRISAN, when I was there, I used to organize such courses for contractors, officials. They were very popular. 5 days or 7 days program was there, on payment, of course. So they will pay for their own whatever step, but they were very immensely popular. So I'll suggest to maybe AMC and the director or DG IRISAN to think of such, giving this opportunity. Second is the documentation. I think yesterday, today, every day we are talking documentation. Now in this, there were good presentation, good like this bridge regirdering work, or even by the today we saw by the IPCL also. Yesterday, Ircon also said CTP12, very good work was there. But there is a need to now produce some sort of a documentation. It could be by way of film. Because we may talk at length, hours together, but understanding is more clear unless if I see something happening in front of me. So through the videos, through some sort of film, this will be an excellent contribution to the railway fraternity. Last not the least, in this area I want to say that now there is a dearth of the railway officials who are really knowing about railway engineering. So whether by the contractor side, whether by the PMC side. So my case is that we retire because there is an age limit given by the central government, 60 years. But 60 is hardly any age for retire. People are very healthy these days. So they go up to any, whatever, 70, 75. So these people are very much available. You should have a database. It can be for Group C, Group B, Group A. All these are people who are really able to contribute their might. Because everybody wants to see success of the organization. So whatever authorities are there, they can chuck it out in what way this can be benefited. So these 3 suggestions are there on the paper 1. Now paper 2, really it was a very good paper from this point of view, that it was like covering a grey area. As he said, we were all looking at the buffers in a different way. It's a very small component. But you know, must have heard the famous proverb that weakest link in a chain is the deciding factor. So whenever there is an accident or derailment or something, this will be the weakest link. So I'm happy some effort have been made, but my suggestion is standardization should occur, that every contractor need not develop a new model, because otherwise it will happen, all the contractors producing some 3 models or 4 models, and then at the end of it you will have more inventories and maintenance problems or issues are there. So let the RDSO decide which is the best design, and then that can be copied. Paper 3 was about raising speed for semi-high speed trains. It's a very good case, curve alignment. But I will agree with my co-chairman that whether it will be adopted or not, because there are various other issues which have to be aligned together. So I will only say that even field officers may also be reluctant to adopt this methodology, because ultimately there is a constraint of blocks, constraint of manpower, constraint of machines which will be handling this type of heavy track structure. So we may have to find some solutions. So my suggestion is that you can take up some section as a small for trial or whatever purpose, and then scale it up. Because as a large scale, you cannot have like one entire section to be upgraded to whatever 200 kilometer potential by putting in some cost. But on this paper, I would like to personally compliment Mr. Satya Prakash. He has presented 2 papers, one in the morning half and today. So I think this is a very well written paper. Now I will suggest DGR Irisen to see that some books can be brought out by good faculty. So like I remember about 13 books were brought out in my tenure in 2004. So there's a good talent available Irisen all the time. So they can produce some book on a particular topic. It could be on this topic, it could be another topic. So it will be a very good resource for the people to learn later on. Then paper 4, leading paradigm shift. So I think we all, when we joined our service, we knew this problem is there ever since, like Rajdhani train was introduced in the Allahabad division. So there, CRS had given this recommendation that it should be fenced both the side, but we could not complete it till now. Later on, Shatabdi was introduced in Jhansi routes, again same problem. So all 50, 60 years have gone, but no half-heartedly attempts are made. Now when the DFCC track also is being made parallel to the railway track, this need is more accentuated. So now we have to see that somehow this type of whatever fencing could be 3 method which he has spoken. 4th method has been suggested by one of our colleagues, Mr. Malik. So you can decide which is good method. But personally speaking, if you ask my choice, PSC will be much better choice. So we have to make some standard design so that we can do the fencing of this entire track. Then paper 5, which was about RDSO regarding that track inspection technology. Now I look back, when we joined railway service, it was Amsler car, then it became TRC, then it became TRRC, now it is today ITMS. But still we must complement RDSO, even if they have taken 50 years. But this looks to be quite a modern device to give a tool to the PWIs or the engineers at the field. At least they will have a good mechanism of recording all the parameters in one go. It is almost like today we go to a surgeon, now he is operating through laparoscopic method. We call it, it's a very good method. So why engineer cannot be equally complemented by giving such type of output? So I think we must make sure that RDSO does this type of work and which proliferates all over the Indian Railway. Sorry? Yeah. And lastly, Halliday was much, I think, I covered only Amsler. He is covering even 1/5, the lowest version was Halliday recorder. So before I sum up and conclude, I will like to take this opportunity, because this is one session when we chair, we must compliment the organizers, PC Western Railway, PC Central Railway, for having really made excellent arrangement for the seminar, for our stay. So 3 claps for him, his team. And to the IPWE management for conceiving these topics and calling all the people from all over the Indian Railways for this seminar. I find DG Irisen also sitting in front of me, is my ex-colleague. So some recommendations always flow at the end of the seminar which go to Railway Board and they are processed for whatever purpose. So I hope whatever recommendation you are framing or going to frame till afternoon, please find some space for whatever valuable suggestion if it is worth in your recommendation. Thank you very much. With this, thank you for sparing so much time for listening to my whatever advice. Thank you.
All right, thank you so much, sir. So, ladies and gentlemen, let's begin with the presentation of the mementos to our respected chairman and the co-chairman. And for this, I would like to call upon Shri V.K. Gupta, AMCE Railway Board, chief guest for today. I request him to please present the mementos to our respected chairman and the co-chairman.
And we also have Director General of IRISEN, Shri R.K. sir. So thank you so much for doing the honors, and thank you so much. We see the camaraderie that the both of you have and the way you brought him on the stage as well. So we are looking forward to taking group pictures with everyone and all the authors as well. So I would request all the gentlemen on the dais to stay there and give the opportunity to all the authors to take a group picture with all of you. Sounds good? All right. So can we present the mementos, please?
Ladies and gentlemen, floor. All right, thank you so much, RK sir. All right, moving on to the next, we're going to have the presentation of the mementos to all the authors by Shri B.K. Gupta, AMCE Railway Board. And for this, I would request all the authors to please come up on the stage, and we're going to have the picture as we have the title of the paper.
So we would request all the authors to come together, and Director General IRISEN, Shri R.K. Yadav sir, thank you so much for doing the honors as well and joining us along with Gupta sir. So can we have, let's do it paper by paper. So all of you together, paper one, all the authors together. Let's go for a group picture. Let's go for a group picture. Yes, once again, one more. Thank you. So we will take a group picture directly. We request the dignitaries to kindly present the mementos to all the authors together and then go for a group picture. Can we have paper 2? Authors are Shri Pankaj Gupta and Shri Veer Narayan. We request both the gentlemen to come together and let's directly go for a group picture. Next, we request Shri Satya Prakash, Dr. Sabyasachi Roy and Shri Bhoj Rathore to come together for a group picture. Thank you, gentlemen. Thank you, authors. Thank you, dignitaries. Next, we have paper 4, Shri Sanjay Khare, Shri Vikas Garhwal, Shri Abhishek Mittal, and Shri Pankaj Chaudhary. We request all of you to come together. Next, we would like to invite paper 5, Shri Rahul Singh and Shri S.K. Banwal. Thank you, B.K. Gupta sir. Thank you, R.K. Yadav sir. Thank you, respected chairman and co-chairman, for chairing this session. Thank you, ladies and gentlemen. And as we can see, the clock is ticking to 1:45. So right now it is 13:45, and we will be seeing you.
So we break for lunch now, as usual. Like yesterday, we have 2 venues for lunch, and the guests are requested to move to their respective venues. We will assemble at 14:30 hours. The session 5 is about papers by industries, and it promises to be a very, quite interesting fair. All are requested to be here at 14:30 sharp. Thank you.